Hi everyone, welcome to my channel. My name is Saldina. I am a software engineer and I make programming and IT related videos here on YouTube. So if that is something that is of interest to you, consider subscribing to my channel. And this video is going to be all-in-one C++ full course for beginners. And the goal of this video is to take you from that place where you are struggling with programming, where you don't understand how to read code or write code, to a place where you feel really comfortable writing code and reading code and you really understand what the code is doing, because that is the most important part. So this course consists of lectures where I will teach you a specific concept, and then there will be a task, and by solving that task you will get a good understanding of that specific concept. And then the complexity of those tasks will gradually increase so that at the end of this video, if you finish it, you will have a very good understanding of the most important programming concepts, not only in C++, but you will be able to take that knowledge with you to other programming languages as well. And then at the end, after you finish this course, in the description I will leave directions for you on what should be your next step, because I have created a roadmap with steps and directions so that if you follow those, you will be able to build your programming knowledge to a very, very high level. But before we start, I want to ask you one question, and I feel extremely proud and happy that you decided to invest your time to learn programming, and I can personally give you many reasons why that is a great decision. But what I'm more interested in is, what are your reasons? Why would you like to learn programming and be good at it? Is it because you are a very creative person, or you want to get a job and earn a lot of money, or you want to gain those problem-solving skills, or because you think that programming is cool? So any other reason that you might have as well, please write that in the comments down below. And then make a public commitment before you start, because that is something that will motivate you. So write, I will learn programming because, and then put your reason and hold yourself accountable. So I am very much looking forward to reading your answer in the comments down below. So without further ado, I will just roll the intro and let's start with the video. Hi guys, very warm welcome to everyone watching this video, and this video is going to be Introduction to C++ Programming Language and the first video of this course. I was planning on dividing this video into two separate parts, so that in the first part I'm going to explain some basic concepts, some general concepts that are related to C++ and that you need to understand, in my opinion, first before starting to write code. And then in the second part we are going to build our first C++ program. So I'm going to include in the description of this video timestamps so that you can navigate yourself to the coding part if you want. But if you're an absolute beginner, I would recommend you to watch the entire video. Let's explain a couple of concepts before we actually start to write code so that you are familiar with them. You may wonder what kind of applications you can build with C++. Well, C++ is general purpose language. That means that it can be used to build all types of applications. So it is very close to the hardware, and that means that it can manipulate resources easily, so you can build operating systems if you want with it. You can build compilers, browsers, demanding games. So all general purpose software can be built with C++. It is not specific for only one domain, but it can be used to solve and build different types of applications. After that, I would like to mention that C++ is compiled language. That means that the code that you write first has to be compiled or converted, translated into another language that is understandable to your machine, to your computer. So that phase is called compiling code or building code. There are certain errors that can occur in this phase, of course, and those are compile time errors. This type of errors is usually the most common among beginners, among people who are just starting to learn C++, and we are going to demonstrate some of those compile time errors when we start coding. After that, C++ is case-sensitive language. That means that C++ distinguishes between lowercase and uppercase letters. So if you have, for example, a variable all uppercase and then a variable all lowercase, so the same meaning, the same word, those two are going to be treated and understood differently as different variables by C++. So it is case-sensitive language. Why C++ was created? Another question. Because before it, there were other programming languages. Well, yes, they were. And it was created in 1980s. And it was created with two programming languages in mind. One of those two was Simula, and the other one was C. So Simula at the time was great language for human way of understanding and representing things. So it was very understandable and easy to use to humans. But at the same time, it was very, very slow. So they decided to combine it with another programming language, a fast one. And at that time, the best choice for that was C programming language. So they combined the two and they got C++. C++ is very, very understandable language, very easy to use by humans. So you can build and maintain huge projects with C++. But at the same time, because of this C part, it is very close to the hardware, so demanding tasks can be executed fast. And also, well, since it was created from C programming language, you can say that any valid C program is actually valid C++ program. So if you've ever built a C program, you have actually built a C++ program already. As I have already said, the code that you write is not directly understandable to your machine. So first, it has to be converted into another language that is understandable to your computer. But the language that is understandable to you is called source code. I am going to put here an example of source code, and I'm also wondering at this moment, what do you think that this code does? So before we started any programming, any coding at all, what do you think that the result of this program is going to be? So just to check how understandable C++ really is, even for someone who has not have a lot of experience in coding. So write in the comments of the video what you think that this code is going to do, and I'm going to check those. So at the same time, you're going to be doing something called writing pseudocode, which means describing what a program does, but just in plain English, so no C++. So this is the source code. After that, that source code is transferred or translated into another form, another language which is understandable to your computer, and that is object code. That object code is usually in the form of binary numbers, so ones and zeros. And that is the only language that your computer actually understands. And this is an example of your machine language. I'm also not going to ask anyone to describe what this here does, because this is highly unreadable and cannot be understood by humans. But as I said, it is the only language that your machine understands. So algorithm, what is algorithm? Algorithm is nothing more than a recipe. So steps, instructions that you write to your computer, list of ingredients and steps that your computer needs to do in order to perform a certain task, that's algorithm. Now that we have understood these concepts, let's switch to more practical part. So the tool that we are going to use is called Visual Studio 2019, and there is a lot of tutorials on YouTube on how you can download and install the Visual Studio, and you can also use community version for free. So when we open Visual Studio, you can see that here in this left part we have our recent projects. So the project that I have recently created. And this may be empty if you haven't used your Visual Studio. So on the other side there is a menu with multiple options. You have the option to check out your code from GitHub here. You can open existing project from your computer and continue working on that. But the option that we are going to use is called Create New Project. So we are going to click that. So this new window now here appears, and we are going to define what kind of project we want. As beginners, we are going to build a very simple app. So we are going to build a C++ console application. So you can type in C++ and make sure to select C++ console application. So not C#, not Visual Basic, but C++. And when you clicked it, you can now when you selected it, you can now click Next. So this new window, now we get a new window where we have to define our project name, location where our project is going to be saved, and our solution name. As default, our solution is named the same as our project. What solution is just actually a group of projects. So if you had a huge application and you wanted to divide it in smaller parts so that it is easier to maintain, you could divide it in multiple projects, but all of those projects would be part of the same solution. So since we are building a simple app, we have only one project and we will name it My First App. So my first app. And location for our project we can either enter manually or we can do it by clicking this button here. And I want my files to be saved on desktop, so I'm going to select desktop. And now we are done with creating our project, so with configuring our project, so we can click create. So the tool that we are going to use, Visual Studio, is an IDE, or Integrated Development Environment. That means that it has a lot more options than just those that we as beginners are going to need and use. So for now, I'm going to explain only the most basic ones, the ones that we are going to need as beginners. But as we progress along the way, I'm going to explain the new features that we'll use. So the first thing that you can see here is our Solution Explorer. So if you cannot see your Solution Explorer, you can click here to this view and select Solution Explorer, and that should bring your Solution Explorer back to view. So as we said, our Solution Explorer is named My First App, and it has one project inside it. So this project is this one here. And as you can see, when we created our project, it was created with some default folders and files. For now, we are going to use only one file, so you can delete these folders, header files and resource files if you want. Just right click and click delete. So now this source files folder is where we are going to put our source code files. If you remember from before, I have said that source code is the code that we write and that is understandable to us. So this is our source code file. So this with .cpp extension. So when we created our project, this file was created by default. And if you double click it, it opens here. So this part here is nothing more than a text editor. Really, as any text editor, it just has these different colors depending on the purpose or the role of the code, so that you can manage the code easier. If it were all the same color, it would be harder to read. So for example, this green part here is a comment. Comment is just a note for yourself. So compiler will not try to translate commented lines. So if you type, for example, here this // or that means actually begin comment, and then you can explain, for example, what this preceding code does. So you can write, this will output to the console hello world. So this will output to the console hello world, so that when you, for example, come tomorrow to this code and you have forgotten what this code here does, this will remind you, this comment here. And these are some default comments, which I will delete now. We are not going to need this. So just select everything in click delete as you would in any regular text editor. This part here also. Now let's explain what we got here. So this include IOStream is actually a header file. So it is also called a library. And this IOStream is input-output stream. So it allows us to input and output data to and from our program. For example, thanks to this, we can use commands such as this here. So cout or console output. So without having this, we would actually have to program ourselves how we will input and output data in our console. So we will not delete this line here. Now check this code here. It says main. Well, that means that this is our main function. So a main procedure that our program is going to execute. So whatever you put actually in these braces here, your program will execute. And the execution of your program begins here and it ends here. So since this here is the scope of your main function, so you can collapse it by clicking here, and you see that everything is collapsed now. So for now, it's enough for you to know that this is our main method, our main procedure. And later in this course, we are going to learn and understand what methods are used for, what is their purpose, and we are also going to create a lot of our own methods. So now we have this cout or console output, which is the command to output to the console. And then we have it also combined with this std and these redirection signs. So std is the namespace for this cout. So that's how your computer knows what this cout really is. I will show you later how you can get rid of this if you really want. And we also have this hello world in quotation marks. Okay, let's see what we have learned so far. We said that this is our solution. Inside it has one project, and within that project we have this file with extension .cpp, which is our source code. So if we double click this file, it brings us here, so to this text editor. And this is our program. This is the code of our program. Now, how we can run this code? Well, see this green play button here? Well, that's our start button. It's really intuitive. So if I click it, we will get our hello world text here, which I have outputted to the console. And you can also see that we have, besides our hello world, we have gotten some junk text here. So what I'm going to do is show you how you can get rid of this in a moment. So let's close our program for a moment. And what you need to do in order to get rid of this junk text is type this command here. So system pause greater than 0 in quotation marks, and the end of command. You notice that at the end of each command, you have to put this semicolon. And if you didn't, it would result in a compiler error, and I will demonstrate that. Let's run our program now, and you will see that our junk text has disappeared. So as I said, after each command, you have to put this semicolon, and if you didn't do that, it would create a syntactic error, and then your compiler would not be able to understand, and your program would not run. Actually, your program would not start. So if I delete this semicolon here, you see that something has changed in this window here. So you see this error red sign. Well, if I hover over it, you see it here, also here. It says expected a semicolon, which is very clearly says that you are missing a semicolon. And if you see this red underline here, it says also expected a semicolon. So before this, you are missing a semicolon here. So if I add it here, our error will disappear. So if you try to run your program before fixing this error, it would prompt you with a window like this. So it says you have 1 failed project and 0 succeeded projects. So this is the code building that I have mentioned before. So this one project, which is actually the only project that we have, has failed building. So your compiler does not actually understand what you have written since you're missing a semicolon. So another thing how you could know that you have syntax error except from this prompt window that we got is this syntax error, so missing semicolon before this closed brace. And if you click it here, it will take you right where you need to go to fix your error. So it's very useful. And if I press my play button again, it now says hello world. So I will stop the program now. You can do it either by clicking this red sign here which says stop debugging, or you can click this X on the console window. So if some other error has happened to you, which didn't happen to me here, you can write that in the comments down below and I will gladly help you. Also, someone else can help you from the other people learning from this video, and I would highly encourage that, since in my opinion the best way to learn something is to try to reproduce what you've learned and to explain it to someone else. So write in the comments if you got some other error. Now let's see how we can upgrade our program. So let's write something else. Let's add, for example, std to column size, console out. So under quotation marks, I will put something that I want to write out. So let's say, for example, my name is Saldina. You can put your name, of course. And at the end of each command, you put semicolon. And let's add one more. So let's say today is Friday. And also add end of command here. So it should write, when we run our program, it should write these sentences in this order here. So you can run your program. And if you can notice, it has this new line in the first sentence. So this is because of this \n. So that puts whatever text is coming after in a new line. So you can put that text in a new line by either entering a \n or with adding this std end line. So std end line, and I have previously stopped my program. If I run it again, you see that we have gotten a new line here. You see also that this std here is becoming a bit tedious to write again and again. And I've told you that I'm going to show you how you can get rid of this. So what you can do is you can put this std on a global level. So you can say using namespace std, and what will that do is reference this std namespace on a global level, so you don't have to reference it every time that you are using it. And now we can delete all of these. So wherever you have written std, that's going to be referenced here now, and you don't need to write it separately. And if we run our program, here we are going to get our result. So we have also this new line added by either /n or this end line here. Okay, so in this video we have learned how we can output data in a console, and in the next video we are going to see how we can input data into our console. So we can ask user to input data, and we are also going to talk about variables and data types. Another thing that I want to show you before I finish this video is, you may be wondering, okay, do I have to start Visual Studio every time that I want to run my program? Is there any other way for me to execute my program? The answer is no, you don't have to start Visual Studio every time. There is another way to start your program from Windows. So let's save all changes that we have made here so far. So you can press Ctrl+S, or if you have made any changes, you see this star here. So it is indicating that you have unsaved changes. So you can right click on that and click Save. And you see that that star disappears now. So let's find a folder where we have created our project. For me, that was desktop. If you followed this tutorial from the beginning, you created it also, and if you followed me, you created it also on desktop. So you can open your folder. You can go to debug, and inside that you see this file here. It says application. So this is your program. So if you right click on that and you check its properties, you will see that it says .exe. That means that it is executable file. So that is your program, that is your application. And if you double click on that, well, you see that it runs same as in Visual Studio. So you can start your program from Windows. Actually, if you want to show it to your friends or someone else, you don't have to open Visual Studio each time that you want to run your program. But one more thing to keep in mind is that if I go to Visual Studio now and I add one more line, let's say we write out "Have a nice day." So, and if I save it, so Ctrl+S, and if I try to open my program from Windows now, what you'll see now is that this new line that I have just added is missing. But why is that so? Well, if you remember, when we were talking about building code, we said that that's the phase of converting source code that you have written into a code that your machine understands. And when you start your code from Visual Studio, it does that process automatically for you. So it builds your code and then it executes your program. But when you are starting your program from Windows, it is missing that phase of building code. So your recent changes, your last changes were not translated. So your computer has the only translated version that it has is the previous one. So without your recently added changes, what you need to do is you either have to run your code from Visual Studio first, or it's enough for you just to build that code inside Visual Studio. And what happens when you do that, so just click here and you can click build, and what happens is your Visual Studio translates this code that you have written and it saves it here. And now when you run it, and when your Windows runs it, it has the latest version, it has the latest changes. So this is the small trick that I wanted to show you. So this would be all for this video, and if you came across to some errors that didn't happen here to me, or you have any questions, you can write those in the comments and I will answer those. And if you watched so far, you can like this video, you can subscribe and share it with someone else who would also like to learn programming, and I will see you in the next video. Hi guys, I hope you are all well, and welcome to the second video of C++ for beginners. In this video we are going to talk about variables, data types, and also I'm going to explain how you can enter data in your program and how that data is encoded into numbers using something called ASCII table. So here I have opened Visual Studio, and if you are not familiar with Visual Studio, or there is some code that you see here but you don't understand it, I would recommend you to watch my first video of this course. The link is going to be in the description of this video, and then come back to this video. So let's talk about variables now. What is variable? Well, I like to explain it through a real life example. For example, you see this glass here. Well, what I can say about this glass is that it is a container for a certain type of liquid. So it can hold water, milk, tea, juice, whatever you want really. And the same way, a variable is a container, but for a certain data type. So you can put whole number inside it, you can put character or a decimal point number or a Boolean value, meaning true or false value. So they are the same in this aspect. Another thing that I can say about this glass is that it defines a maximum amount of liquid that it can hold. So it has a max limit. And if you put too much, it will overflow. The same way with variables. Variables also define a maximum amount of data that they can hold. For example, if you have a whole number variable, well, there is a max number limit for that variable that it can hold. And also, if you put too much, it is going to overflow. It is literally called data type overflow. So it is a container, the same as variable, and also it defines a maximum amount of data that it can hold. But how much data you really put inside that variable? So the same way with the water inside this glass, if you decide to put 1/3 or 1/2 or 2/3 of this glass, the same way is with variables. You can put however much you want as long as you don't put too much, because then it's going to overflow. One thing that is different though between variables and this glass is that you can put one day inside this glass you can put water, the next day you can put juice, the next day you can put milk, then tea, or even you can mix two liquids. But with variables you cannot do that, at least not with ones in C++. There are certain languages that you can do that with, and there is also advantages and disadvantages when it comes to that, but in C++ you cannot put two different data types inside one variables, and you can also not change a data type of variables once you create it. So let me show you what I'm talking about on a practical example. Let's say that you want to create a variable that is going to hold your annual salary. Well, that variable is definitely going to be a decimal point number, or also floating point number. That's how it's called in C++, and the type that is used for that is called float. So I'm going to say float, and then I'm going to give a name to that variable. Since we said that it's going to hold annual salary, we are going to call it annual salary. Okay. And then we are going to assign it a value, and that value is going to be, let's say, 50,000.99. So now what I have done here is I have created a variable called annual salary. I have said that that variable is going to be of type floating point number, and then I have put inside that variable 50,000.99. So now let's see how we can, based on this variable, based on our annual salary, calculate how much our user is earning every month. So what we are going to do is we are going to create another variable. We are going to call it monthly salary, and we are going to assign that variable a result of dividing this annual salary with 12 months. So we are creating a variable of type float also, since the result of division usually can be also floating point number or decimal number, and because of that we are using also float type for our monthly salary variable. So I'm creating monthly salary variable, and I'm going to say that that variable is going to hold result of this expression, annual salary divided by 12 months. And now we have result of this division inside this variable, and what we are left to do is to write that result out to our user. So I'm going to say cout, since that's the command that we use to output data to console, and I'm going to say your monthly salary is, and I'm going to say monthly salary. So one thing to notice here is that when you are writing out strings, or when you're writing out data like this, you use quotation marks. But when you want to write out the value that you are holding inside a variable, well, then you just put the name of your variable. You don't use any quotation marks then. And now we can run our program, and let's see what's the result that we got. You see here your monthly salary is 4,166.75. So if you want to check that out, you can calculate it in your calculator. One thing that that bothers me in this program is that we have hard-coded this value here. So we have hard-coded this 50,000.99. Not everyone's salary is 50,000.99. And what if we wanted our user to enter what his salary is during the execution of our program? So when he runs our program should ask him, what is your annual salary? And then he enters that salary, and then we calculate his monthly salary based on the number that he has entered. So I would like to upgrade this program now to work like I just explained. And how we are going to do that? Well, first I'm going to delete these 50,000.99. Okay. And then we are left with this situation here. So it says float annual salary. That means that I have just created a variable called annual salary, and I have said I'm going to put a floating point number inside that variable, but I have not assigned any value to it yet. So here we have a container for our annual salary, and that container doesn't hold any value. And if we try to run our program now, what do you think that we are going to get? Write that in the comments before I run this program. And now I'm going to, so pause the video and think about it, and then write your answer in the comments. And now I'm going to run the program, and you can see that we have some build errors, as this here, this window here says. So let's see. If we open this part here, it says we have one error, and that error is uninitialized local variable annual salary used. What that means is that this expression here, if you see this green underline, it also says using uninitialized memory annual salary. Well, that means that this expression here, our computer doesn't know how to do this expression, since we haven't assigned any value to our annual salary variable. So it doesn't know how to divide that with 12, since there is no value inside that container, inside that variable. So this causes a compiler error, and whoever has written that compiler error is going to occur, he was right. So what we have to do to correct this is we have to ask our user to enter his annual salary. So what we are going to do now is, let's see first. The command that we use to output data from our program into our console is cout, so console output. And the command that we use to input data is console input, or cin. So I'm going to say cin, and then we use these other redirection signs, and then we say what is the variable that we want to store what our user has entered, and I'm going to say annual salary. So what I have said here is our user is going to console input the data, and then whatever he has inputted, you have to redirect that inside our annual salary variable. So now, if I run my program now, you see that our program runs now, so there is no compile time error. And also our cursor is blinking. Well, it is blinking because it expects here our user to enter annual salary. But this is not really clear to someone who has not made this program. So what we have to do, if I enter some value now, well, it is going to calculate it correctly, but this is not really user-friendly. So what we have to do is we have to write a message to our user before he enters anything so that he knows what he should enter. So before this cin command, I'm going to say cout, and I'm going to say, please enter your annual salary. Okay. And now, if I run my program, you are going to see, please enter your annual salary, and the cursor is blinking, waiting for you to enter the value. And if I say, for example, 40,000, you see that your monthly salary is 33333. So the program has calculated your monthly salary, and the number is based on whatever our user decides to input. So we have upgraded our program. And there is also one more thing that I would like to show you when we are doing this example, and that is, let's say that we want to calculate how much money our user is going to earn in 10 years. So let's say cout, in 10 years you will earn, and now we have to put a value of how much money he is going to earn. And if you look at this situation here, we first created our monthly salary variable, and we then assigned it a value of annual salary divided by 12. But there is another way that we can write out results of expressions without creating any variables, if that is what we need. And that is just here. So in this line, in 10 years you will earn, you add these redirection signs, and then you say expression that you want your computer to calculate. And what we want to calculate is how much our user is going to earn in 10 years. So that is annual salary times 10. And if you do it this way, so if you don't decide to create a variable, then you will not be able to use the result of this expression later in your program. So you don't have a container that holds this 10-year salary, but you have a container that holds annual salary and monthly salary. So each time that you want to write out or do something with your 10-year salary, you will have to write this expression, while if you want to do something with your monthly salary, you have a container that is holding that value directly for you and you can access it. So if we run our program now, you see it expects us to enter our annual salary, let's say 50,000. And you see here your monthly salary is 4,166.67, and then in 10 years you will earn, what is this, 500,000. So okay, one thing that we are missing here and that you can add is end line or \n. So you can add it here, and your program is going to format your text nicely. So this line should go here like this. If I add here one more end line, and if I run my program again, you see enter 50,000, and now we have our text formatted nicely because of this end line that I have just added. Let's now create another variable, and this time we are going to create a variable of type character. So char, that is the type that is used for character variables in C++, it's called char, and let's name our variable character. And when you want to assign a value to a character variable in C++, what you use is these single quotes, like this. If you see this example here, when we are writing out text, so string of text, we use these double quotation marks. But when you want to assign a character value of a character variable, we use these single quotations, like here. And there are also some more rules when it comes to naming your variables. And the most important one, in my opinion, and the most important one to make it easier to you, is to name your variables according to their purpose. So give meaningful names to your variables. That is really, really important. For example, you see this monthly salary variable here. We could have as well named this variable blah, 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 and copy it here also, because we are having compiler error right now, because our compiler does not know what this variable really is. You see, it says identifier is undefined because you have not created this variable here, because it supposes that it is a variable, but it has not been created before, so it does not recognize what this variable is. So we have to copy the new name here also, and now our compile time error disappears. And this here, this name, does not represent anything to your computer. So your computer is now going to run your program, and your program is going to work just the same as it did before. But this is really making it hard for you to understand what your code is doing. And especially if you come to this, for example, in 10 days, or someone else tries to understand your program, this is really hard to read. And he will just try to uncover really what your program is doing without understanding it, because you have used these blah 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 names for your variables. The same situation would be if you, for example, have 3 boxes inside your kitchen, and you use one for storing sugar and flour and salt. And instead of naming those sugar, flour, salt, respectively, you decide to name them red box, green box, and blue box. And then someone else comes to your house, someone else comes to your program, he does not really know where to find sugar, because red does not mean that that box is storing sugar. So you should name that box sugar box, because imagine 3 is easy to remember, but imagine having 10 boxes or 10 variables or 100 of them, or even 1,000, which is very common inside large programs. So what you should do, and I am going to do, is return that previous name. So monthly salary, and here also. So you should give meaningful names to your variables. That is very important. And that is the first rule. The second rule is that, well, the second and third and the fourth are the rules that you will have to obey in most cases, because if you don't, then you are just going to get a compile time error in 99% of the cases, let's say. And I'm not going to say what that 1% is, because I want you to obey these rules. So when it comes to naming your variables, another thing is that your variable names cannot contain any special characters except underscore. So like this. This here is valid name to your variable. But if you try, for example, to name your variable like this, so you say plus character, you see that here in this error window it says expected an identifier. So you cannot use this to name your variable. Or this, you cannot say character with this minus inside it, so character minus ter. So these signs, these special signs, are used for something else. They are operators inside C++, and you are not supposed to use those inside your variable names. If you really want to use some special signs, what you should and can use is underscore, like this. So this is the only sign that is allowed and that I recommend for you to use for naming your variables. That's the second rule. The third rule is that your variable names cannot begin with numbers, like this. So you cannot say 8 character, for example. It also says expected an identifier, but what you can do is you can say, for example, character 8. That is a valid name. So a number can be on any other position except on the first position. So this is a valid name for a variable. So you can put also number here. So you can say, for example, C12 character 8. But again, what does that really mean? That is not a meaningful name for a variable. So again, we come to the first rule. So you should name your variables according to their purpose. So I'm going to return this to character name again. And then we have our third rule, I guess, which is you cannot use space inside your variable names. So for example, this is not valid, and your compiler says it here. So it gives you an error. It does not know what this really is. So you cannot use blank spaces inside your variable names, because you are going to get a compile time error. And if I try to do that and I try to run my program, I get the window. So it says, you cannot run this program. You have syntactic errors. What you should do is you should correct those errors, and then you can really run your program like this. Okay. So let's repeat these rules one more time. The first rule is that you should give meaningful names to your variables. So name them according to their purpose. The second rule is that your variables cannot contain any special characters except underscore. The third rule is that your variables cannot start with numbers. You can put number on any other position, but not on the first one. And the third rule is that, and the fourth rule actually, is that your variables cannot contain blank spaces. So empty spaces, no in a variable name. What you should do is you should name your variables according to their purpose, so meaningfully, and you should also use something called camel casing. What is camel casing? You see how I have named this annual salary here. You see that the first letter of my variable name is small letter, and then the next word starts with capital letter, and that is called camel casing. So for example, you would name your variable like this: first, second, third. So like this. You see that this first, second, third, these are words inside your variable name, and this F is lowercase letter, that's the start letter of your variable, and then each next word begins with capital letter, and all the rest is lowercase letters. That is called camel casing, and that is something that is usually used with C++. Let's talk about data types now. I am going to delete this code, so if you need this code for a bit longer, you can pause the video here. So, what kind of data can we store in our variables? Well, for now we are going to cover only the most basic ones, the ones that we are going to use frequently, and you should know that there are a lot more data types besides from these that we are going to mention here, and more complex ones that we are going to cover later in these videos, in this tutorial. So the first one that I would like to mention is a whole number data type. So integer, a data type that can hold negative whole numbers, 0, and positive whole numbers. So the type that is used for that in C++ is called int. And good example for int variable is, let's say, year of birth. So that is an example of a whole number variable. And let's say that that variable is going to hold 1995. Okay, so that would be an integer variable. After that, we have already seen this. So it is a character variable. So let's say char. And an example of a char variable could be gender, for example. Let's call it gender. And you can store F for female or M for male, for example. So the char variable can store one character. Then the next one is Boolean value, meaning true or false value. This is the simplest one, and the type that is used to store Boolean is called bool. And a good example for a bool value could be, for example, if you want to hold in your program a variable that tells you whether your user is older or younger than 18 years old. So let's call our variable is older than 18. And we can assign to that variable either value of true or false. So I'm going to put true true here. Another variable, another data type is decimal point number, also called floating point number, which we have mentioned before. And let's create a variable of type float. And let's say that that variable is going to hold our average grade. So average grade. And this average grade can also be a whole number, but since it has potential to be also floating point number or a decimal point number, we are going to use a float data type for this average grade. And another data type that I would like to mention for also storing decimal numbers is called double. And the difference between double and float is that double is double size of float. So if you remember when we talked previously about taking memory space that variables take, so float is taking 4 bytes and double is taking double of that, so 8 bytes. So you can put much more data inside your double data type than inside float. And let's say, for example, that if you had a credit card and you had a lot of money, a lot of money, and you want to store that value inside a variable, you would use a double data type. So let's say double balance equals to this large number here, which I'm not going to even try to read. Okay. So these are the most common data types that we are going to use in this tutorial. I have said earlier that each data type takes a certain space in memory, but let's see exactly how much each of these take. For that, we are going to use something called size of operator, and let's see how we use it. So cout size of int is, and then we write this size of. So size of, and in parentheses we pass to it data type that we want to check how much memory it is using. So int. And if I run my program now, you see that it says that int takes 4 bytes of memory. And if you've ever actually studied binary algebra, you would know that 4 bytes of memory is actually 32 bits, since each byte has 8 bits. And as we said, our int can store both positive and negative numbers, and 0 also, remember that. So the first of these 32 bits is used to determine whether the number has plus sign or minus sign, so whether it's a positive or a negative number, and then remaining 31 bits are used for this value itself. So let's check what is min value for our int. Let's write that out. Let's write cout int min value is, and we have a reserved word for minimal amount for int in C++, and that is int underscore min. And if I run my program now, you see that it says this minus 2 billion, extremely hard to read this number, but you see that this is the minimal amount of int. So this number is actually 2 to the power of 31. Let's just quickly write these. So minus 1, minus 2, minus 3, and then minus this number here. So this number, as I said, is 2 to the power of 31. Why not 32? Because this 1 byte is used to represent this minus prefix. Now we should check a positive number range. So we also can write int max value is, and then there is another keyword in C++ for int max, which is int underscore max. And are you expecting to see this same interval but just with plus sign? So write in the comments, what are you expecting to see? And if I run my program, you see that that did not happen. And if some of you know why it did not happen, I would also like to hear what you think, why we have this number here and then this number here for our negative and for our positive range. So different ending number. And I'm going to explain why. Because this positive range here, we have to include 0 also. So in order to include one number here, let's just copy this and paste it. So our positive range is going to from 1 up to, let's say that it is this number, but since it is including 0 also, in order to include one number here, so 0, you have to take one number here. So this here is not 8 anymore, but is 7. So that is why we got, let's say, different number for our positive and negative range, because this here includes 0 also. One thing that I have to mention though is that if you want to use only positive integer numbers, there is a data type for that as well. And the data type that is used for that is called unsigned int. And its size is the same as of int, so 4 bytes or 32 bits. But since it is unsigned, that means that it does not use 1 bit for sign, because the sign is by default plus, but it uses all 32 bits to represent value, and those values go from 0 to, let's see exactly how big of a number, 4 billion and something. So cout size of unsigned int is, and let's see size of unsigned int, this is the data type. And let's also write out what is the max value of unsigned int. So let's say cout uint max value is, and there is also a reserved word for that, and that is uint underscore max. So if I run my program now, you see that we got 4 billion and something number, so double the size of this. And this is actually 2 to the power of 32, but minus 1, because we are also including 0 in this range. So let's check these remaining data types. I'm going to write those out quickly and I will be back. So I have written here the rest of these data types, and as you can see, since our bool is only true or false value, 1 byte is enough for bool. Our char is using also 1 byte, float is using 4 bytes, double is using 8, and I'm also going to include a table with some more data types which we haven't mentioned here, so if you need to check those out, please pause the video. One thing that I promised to show you is data type overflow. Let's see what that is. So let's create a variable of type int and call it int max, and let's say that I want to store inside that variable maximum amount of int, so int underscore max. And I'm going to write that variable out now just to see how big of a value that really is. So cout int max, and if I run my program now, you see that I have gotten here this 2 billion, very large number actually. So that is the max amount of int. Now my question for you is, what is going to happen in this situation? So cout int max plus 1. What is going to be the result of our program now if I run it? So some of you may know this already, some of you may not, but I am very interested in reading your answers. So make sure to write your answers before watching my explanation on this. Write those in the comments down below. And if I run my program now, well, our number has not increased by 1, but it has went to the minimal amount of int. And why has that happened? Well, that is the data type overflow that I was talking about. And how this works actually is it works the same as your clock works. So it goes 9, 10, 11, 12, and then from 12, since that is the max value on your clock, it does not go to 13, but it goes back to min, so 1, 12, and then 1. And that is applicable here. It went from the max value to min value just by adding 1. And that is called data type overflow. I already can see that this video is pretty long, and I'm currently having problems uploading very long videos to YouTube. So I'm going to leave for the next video explanation of ASCII table, and we are also going to do some more examples and practice C++ some more. So make sure to subscribe to my channel and also click the bell icon so that you are first to be notified when I upload my next video, and also like it and share it with anyone who you think could benefit from this video. And I will see you in the next one. Hi guys, welcome to my channel. As I promised in my previous video, in this video I'm going to explain the concept of ASCII table, and then I'm going to give you an idea, an example of a program that is very beginner friendly, very simple, but also very fun, and that you can build only with knowledge from my 2 previous courses and this one. So if you haven't watched those, make sure to watch them. Link is going to be somewhere here and also in description. And also make sure to like this video and to subscribe to my channel for more educational content. And let's begin now. So what is ASCII? Well, ASCII stands for American Standard Code for Information Interchange, and it was first created in order to standardize the way of representing characters in your computer. So in ASCII table, those characters are represented as numbers, numeric codes. And what this means is following. Let me give you an example. When I first learned to read and write, so when I was a little, I decided to, together with my friend, create our special symbol language, where we would exchange each character with a special symbol that only 2 of us could understand, and then we would exchange letters using that symbol language, and no one else could understand those letters. And also, guys, write in the comments down below if you did that. I know you did, so don't make me feel like a weird one. Well, that is exactly what your computer does. It exchanges each character with a number so that it can understand it and it can communicate with other computers. So this means that your computer or ASCII table assigns to each character a unique number. And let's prove that now. So how we can do that is, in my Visual Studio, I'm going to say cout. And then in these parentheses, I'm going to say int, and then these single quotes, and I'm going to say letter A. And let's add end line. So this is one way of doing that, and then there is another way of doing just the same thing, and that is, let's say cout, and then int, and then inside these parentheses, we are going to say our single quotes and our letter A, and also add end line. So this here is called casting operator, and it is the operator that forces one data type to convert into another. And since we said that each character has its numeric pair inside ASCII table, well, we can ask our computer to give us that pair. So here I'm saying, please tell me what is my numeric pair of my letter A. So what number is my letter A? And if I run my program now, you see that I got 97. So our lowercase letter A is 97 in ASCII table. Let's check now a capital letter A. So I'm going to say cout, int off, and let's put our capital letter A and one more end line. So if I run my program now, you see that I'm going to get a different number, so 65. And this is so that your computer can distinguish between lowercase and uppercase letters. So ASCII uses 7 bits to represent each character, and that means that it can represent 2 to the power of 7. That's how much characters it can represent, so 128 characters. And that is enough for all English characters, so all English lowercase and uppercase letters and numbers, and also some special symbols. But there is also a lot more languages, and also languages that have a lot more characters. So there is a lot more standards for representing those characters inside your computer. So this that we have just mentioned is called ASCII, and there is also extended ASCII. That is another standard that can represent more characters. Then there is also UTF-8, UTF-16, and a lot more different standards. So what we should remember for now that is related to ASCII is that ASCII represents each character with a number, so it holds its numeric match, its numeric pair in its table, and then that we can also get that numeric match using our casting operator. So this here is a casting operator. So now you may ask, if we can get a numeric value of our letter, so if we can get our int number of our letter, can we do vice versa. So can we get a character from our numeric value? And the answer is yes, we can convert a number into a letter also, and I'm going to demonstrate how we can do that in a moment. So you can say cout char, and let's say char of 65, and add end line. And if I run my program, you see that I'm going to get a letter A, so capital letter A. And now with this, when you learn this, you can get an idea on how you can build something more useful than just basic Hello World application. So you can, for example, build a program that ciphers words and sentences in an ASCII, and then also a program that deciphers those messages back into English readable characters. So now we are going together to build a program that ciphers words into ASCII codes, and then I'm going to leave to you to build the program that deciphers those words back into English readable characters. So let's say that we want to cipher a 5-letter word. So what I'm going to do is, what I need to do is to create 5 char variables. So I'm going to create 5 char variables, then I'm going to let my user input his letters inside those 5 char variables, and then I'm going to write out encoded words. So I'm going to convert all of these letters in ASCII codes, and then I'm going to write that out to my user. So I'm going to, in a certain way, cipher his word. So I'm going to say here char C1, char C2, and then char C3. And I want to stop here for a moment. I want to explain one thing. When we first were talking about creating variables, we said that this is the way of creating variables. So you say the type of your variable, so char in this case, and then you say what name you are going to give to your variable. So in this case, this is our C1, C2, C3. So this way of creating variables here, it is correct, but it is a bit tedious for this current situation. There is another way of creating more than one variable, and I'm going to demonstrate that now. So what you can say also, what you can do is char C1, C2, C3, C4, and C5, and all separated with this comma sign. So you can create more than one variable in one line like this, but only if all of those variables are of the same type. And in this situation, they are. So all of these variables are of type char. So I've now created 5 variables of type char. And another thing that I want to mention is that in upcoming videos, we are going to learn how we can let our user decide how many characters, how many values he wants to enter during the execution of our program. So now we have hard-coded these 5 values, but we are going to learn more in the following courses. And also another thing is that also in C++, there are a lot of solutions that you can use already made so that you can enter whole words or sentences, so you don't have to enter your word letter by letter, so you don't have to create variable for each letter that you want to enter. But what I'm trying to explain here and what we want to understand here is how it really works in the background, so how it works inside. You have to understand that, and I believe that that will give you a great advantage over those programmers that just know how to use something rather than how to make that something by themselves and then use it. So I have here created 5 variables, and each one to hold a character that we will enter, and let's enter them now. So what I'm going to say is cout, enter 5 letters, and then I'm going to say cin, and I'm going to put all my variables here. So C1, C2, C3, C4, and C5. So if you can see here, I have entered all of my 5 variables in a single line. So you can do this. You can bind these operators like this so that you can enter more than one variable in a single line. The same way that you can bind your cout operator so that you can write out more than just one string. So now what we are left to do is we have to write out our ASCII message. So So what I'm going to say is cout ASCII message, and then I'm going to put int C1. Let me write that out really quickly. So I have written this message here, and what I have said is console output ASCII message, and then I have combined these cout operators so that I can write more than one variable in a single line, so in a single command actually. So I have said give me my int code of my C1, so give me my ASCII code of my C1 variable, and then put a blank space, and then give me my ASCII code of my C2 and also C3, 4, and 5. And I have also used these blank spaces because I don't want to write just a single number in a single line, because I want to know where my first character ends and where my second character begins. That's why I'm going to separate those codes with an empty space. And also there's another thing that I want to mention, and it is that when you want to convert your variable, so the value that you're holding in your variable, and when you use your casting operator on that, you don't put your variable in a single quotation marks, you just put the name of your variable, like this example here. So if I run my program now, you see that I get my message, so enter 5 letters, and I'm going to enter hello, and you see now that I have this output ASCII message is 104, 101, so 108 and 108, so that is our letter L. You see that it has the same code, and now I have gotten this ASCII message which is our ciphered word. And also there is one thing that I want you to keep in mind, and that is that this program here will not take into consideration your enter or your space key as a letter. So if you put your enter or your space key however much times you want, it will not treat it as a character. There are some other functions that you can use in your C++ if you want to capture your enter, for example, or your space key, such as cin.get. If you really want, you can Google that out. But at this point, we are keeping this very beginner friendly, so this will not capture your enter and your space. So let's just prove that. I'm running my program once more, and I'm going to put enters and spaces, and you see nothing is happening. And then if I enter hello once more, you see that I'm going to get the same numbers, so the same message as before. So we have built here a program that ciphers our words into ASCII, and we have built this program after just studying a little bit of coding. So imagine what you can do if you learned more. So stay tuned, make sure to subscribe to my channel, and also like this video if you want to support me in filming these videos. And also I'm going to leave to you to write a program that is going to decipher these messages from ASCII back into readable English words. So you also can put your suggestions of a code in the comments down below. And also what you can do, you can upgrade this program here that we have written so that you can put in more words, more sentences if you want, and then you can put those encoded messages in the comments, and everyone who wants to read those messages is going to have to build a program that is going to decipher those messages into readable English. So subscribe to my channel, like this video, and I'll see you in the next one. Hi guys, welcome to my channel. In today's video, I wanted to show you something that you are going to be using very often if you start on a programming path, and that is if-else statement. So what is if-else statement? Well, if statement is something that is used when you want to execute part of your code, so block of your code, conditionally, which means not always, but only in a certain situation. And then if you add else block to that else block is going to be executed otherwise. So in the situation where your if block is not executed, your else is going to be executed. So let me explain that to you in a simple example. Here I have opened my Visual Studio, and let's quickly paste an exercise that we are going to do in this tutorial. And that is this task here. So let's say that our user has to enter a number, a whole number, integer number, and then after that our program has to check whether that number is even or odd and has to write out that to our user. So how we are going to solve this problem here? Well, I'm going to explain this to you using diagrams, because I believe that that is the best way for you to understand this if you haven't used this if-else statement before. And then what we are going to do after we understand those diagrams, well, we are literally going to just translate that diagram into our C++ code. So let me open my tool. Here I have opened a tool that I'm going to be using for drawing diagrams. It's called Blank Diagram. You can use whatever tool you want. You can use even a paint or a pen and paper if you want. That will work as well. So here I'm going to draw the flow chart of our program, so how our program is going to be executed. And let me add first here this shape, and we are going to say that this is going to be the start of our program. So I'm going to write out start, and this indicates our main function, let's say the first line of our main function. So here our program starts. And then, as we said in our task, in our exercise, our user has to enter an integer number. And the shape that we are going to be using for that is this shape here. So let me put this shape here. And I'm going to write a text inside, and I'm going to say int number. So this shape here indicates that our user is going to enter some data in our program. And why I'm using this shape? Because it looks like this. It looks like a funnel. So you can clearly visualize that something has to enter inside that shape. So something has to be inputted in your program. So I'm going to use this shape for that. And then I'm going to say that our user has to enter an integer number, which I'm going to call number. So that variable I'm going to call number. And let's quickly add this arrow so that we know that this is the flow of our program. So after it has started, our user enters a number. And then after that, what we have to do is our program has to decide whether that number that user has entered is even number or odd number. So how we are going to do that? Well, the shape that I'm going to be using for that decision, let me find it. Well, it is this shape here, so this diamond shape. And as you can see, it says decision on it. So that's the shape that we are going to be using. And inside this shape here, I'm going to write a condition. So as you can see, our program flows this way. And after it comes here, as you can see, it has one entry point, and then it can have multiple flows that it can go to, depending on this condition that we are going to put inside here. But how we are going to decide whether that number that our user has entered is even or odd? Let me very quickly open my Visual Studio once more. It is here. And let me show you something. I want to introduce you to an operator that is called modulo, and that is used to show what is the remainder of dividing two whole numbers. So I'm going to write out cout, and then what I'm going to write out is, let's say, 2 modulo 2. So this operator here gives you the remainder of dividing these two numbers. And in this situation, we are expecting to see a 0, because 2 divided by 2 is 1, and then what remains after that operation is 0, and that what remains should be shown when we use this operator here. So if I run my program, you can see that we have gotten the expected result, so we have gotten 0 here. But let me show you what happens if I enter, for example, 5. Well, what we are going to get is 1, because 5 divided by 2 is going to be 2, and then that 1 that remains we can get using this operator, and you see that it gives us the expected result. So 5 modulo 2 is equal to 1. So this operator here is what we are going to be using to determine whether our user has entered even number or odd number, because when we get the result of modulating two numbers, when our result is 1, that means that our user has entered odd number. And if we get 0 as a result of this operation, that means that our user has entered even number. So I'm going to switch again to my diagram, and then inside this decision here, we are going to be we are going to write this condition here. So I'm going to say number modulo 2 is equal to 0. So what this means, it means that after our program has started and our user has entered the number that he wants, an integer number, we are coming to a decision point where we have to decide whether this number that he has entered after you modulate it with 0, whether it's a 0 remainder or some other remainder. So in this situation, when this is 0, we are going to execute a certain part of code. And then let me add very quickly, oh, I'm impressed. It already has this yes inside it. And then we also have this no on this other line. So in this situation where this results as an operation that is true, we are going to execute this part code of here. So I'm going to add another shape, which I cannot see. But let me use this shape once more, and I'm only going to rotate this shape like this. And I'm going to delete this text. And what we are going to be using this shape here for is to indicate that we are going to output something from our program. So it looks like this, which is clearly a visual of something is going to be outputted from it. So it is just reverse of this shape here, this funnel shape. And then inside this shape, let me write a text which is going to be, let's say that in the case that this here results as a yes, as a true operation, so our number, when it's modulated by 2, it gives a 0 remainder, we are going to say that that number is even number. So we are going to write that out to our user. And then in the situation where this here results as a no, so as an operation that is false, let me write out that here, and I'm going to say to our user, so I'm going to write out to my user that he has entered odd number. And let's just join this here like this. Okay, so our user enters a number, then we decide if that number modulated by 2 gives us 0, and if yes, we are going to write out to our user that that is an even number. If no, we are going to write out to our user that that number is odd number. And this is here really our program. What I'm going to add is, let's say that after this, our program is going to stop. So I'm going to say here that this is the end of my program, like this. And let's add one more stop of this flow here. So in both of these situations, after we have outputted to our user the result of this program, our program is going to stop. And this here really, like these two stop points, look a bit ugly to me. So what I'm going to do instead of this, I'm going to delete this. You could have as well left it like this, like it was before. But what I'm going to add one more of these diamond shapes, only this time it's going to be smaller. And I'm going to say that in this situation, it is going to be used only to say that this decision here, this decision flow is going to be joined in this point here. So like this, I'm going to say whatever has happened, whether this block of code or this block of code, it has come to an end here. And then after that, from here, I'm going to say, now my program is going to stop, like this. And this, let me remove this yes. And this is going to be the flow chart of our program. So our program starts, then our user enters integer number. Then we decide whether that number modulated by 2 is going to give us 0. If yes, we execute this. Else, we execute this. So if this is no. And then we come to this, which joins our two paths, and then we can say that our program has ended. And now let's translate this to our code. Here I have opened both my Visual Studio, and also I have exported this diagram so that we can translate it literally. We can look at this diagram and then translate that into code. So now I'm going to delete all of this that we have written inside our Visual Studio, and I'm going to look at this picture and just translate it into C++ commands. So the first this first shape here says that user is going to enter integer number inside our program, and we are going to call that variable a number. So I'm going to say int number, and then this here, this funnel shape, really translates into cin command. So user enters something inside our program, and that is cin command, and I'm going to say that user is going to enter a number. Before this, I would like to add one more information to our user so that he knows what he should enter. You could have as well put that to our diagram, but I didn't want it to make that diagram crowded, so I didn't. But what we are going to add here is cout, and then say, please enter whole number, like this. So we write out a message to our user, and after that our user, as you can see here, enters integer number. We had also to declare this int number variable because you can enter the value only for variables that you have previously declared. And then after that our program comes to this decision point. And how we can represent this decision inside our code is using if statement. So we are going to write here if, and then I'm going to put this condition here inside these parentheses. So I'm going to say if number modulo 2 equals 0. This here is operator of equal. So whether this side is equal to this side, since only one of these, so like this operator here is used to assign value to a variable. So that was already taken. So this here, two of these signs are used to check equality of these two sides. So whether this is equal to this. And then what I'm going to say, as you can see from my diagram here, we check this condition here. And if this condition is true, if this condition is yes, we are going to execute a certain block of code. And that is this code here. And how you indicate a block of code in your C++ is using these braces here, like this. So this is your block of code that is going to be executed in this yes situation. And then in case that this no here happens, so in case that this results as false, you are going to execute another block of code, and we represent that block of code using else statement. So we are going to say if this here is true, execute one block of code, else if this here is false, execute another block of code. So here, what our if makes us do? Well, it says that we only have to write out to our user that he has entered even number, because this shape here, as you can see, it looks like this, and it represents that something should be outputted from your program. So we are going to use for that our cout command. So cout, you have entered even number. So like this. And let's add end line. So in case that this here results as true, we are going to output to our user that he has entered even number. Else, if this here results as false, we are going to output to our user, let me copy this, like this, and we are going to change that only to odd. So in case that this here results as false, we are going to output you have entered odd number. So either this here is going to be executed or this here, depending on this condition. And you can see that from diagram clearly. So when your program comes to this decision point, it checks this condition, and if the answer is true or yes, it is going to execute this. Else, if the answer is no, it is going to execute this. And then after that, it really just joins these two flows, and then that is the stop point of your program. So we can write here cout, thanks, bye. Okay, let's say that is the last line of our program. I haven't put this on my diagram. Okay, so I'm going to run my program now, and as you can see, it says please enter a whole number, so this line here. And if I enter, for example, 8, it is going to come to this line here, and it is going to modulate our 8 with 2, and if the result is 0, which it is going to execute this line here and write out you have entered even number. Oh, thanks. We are missing an S here. And then it writes out thanks bye. And let me add an S here. Okay, and if I run my program again, as you can see, it asks me again to enter a number, and this time I'm going to enter 5, which we know that is an odd number. It says you have entered an odd number because it has come to this decision point here. It has tried to modulate 5 with 2, and the result of that was not 0. So it has not executed this, but it has executed this else statement, and it has written you have entered odd number, as you can see here. And then this thanks bye. Okay. So I hope that you have understood this, and if you like me to use these diagrams to explain some more code that we are going to be using, you can write that in the comments down below, and I'm going to try to use more of these diagrams because I know that some people understand it better when there is a visual representation of your code. I was one of those people when I first started learning programming, so if you find it easier to understand when I use these diagrams, I'm going to be using that. So thanks for watching this video. Make sure to like it if you find it any helpful, and also to subscribe to my channel, and I'm going to see you in my next video. Bye. Hi guys, welcome to my channel. In this video I wanted to talk about if-else statements, but a bit more complex if-else statements so that you can get an idea on how they are used in real life. So if you're not familiar with them at all, like you have never heard of if-else statement, then you should probably first watch my first video of this subject, and I'm going to link it somewhere here, and then you can come back to this video. But if you're already familiar with the very basics of if-else statements, then this video is right for you so that you can upgrade your knowledge. So keep watching. So the problem that we are going to solve in this video is the one that students usually get on their exams a lot. And with the knowledge that you get from this video, you are going to be able to recognize and solve other problems of this type. And also, if you don't want to work with C++, this logic that I'm going to teach you today is going to be applicable in other programming languages as well. So here's the text of my problem, and it says that our user should enter the side lengths of a triangle, so A, B, and C. And after that, our program should write out whether that triangle is equilateral, isosceles, or scalene triangle. And as you already may know, equilateral triangle is the one that has all 3 sides of the same length. Isosceles triangle has 2 sides of the same length, and then scalene triangle is the one that has all 3 sides of a different length. So the way that we are going to solve this problem is we are going to really visualize the solution for this problem so that you can really understand it, and that is going to be using diagrams. The tool that I'm going to be using for drawing diagrams is called Blank Diagram. You can use whatever tool you prefer, even pen and paper if you want. And the first shape that I'm going to put to this diagram is going to be this circle shape here. Let's say that it is going to indicate the start position of our program. So here's where our program starts. And after our program has started, what we want is we want our user to enter side lengths of our triangle. And the shape that we are going to be using for that is this funnel shape here, so that you can clearly visualize, because of this funnel shape, that something should enter inside it, something should be inputted in your program. And what should be inputted is side lengths, so A, B, and C. And the type that I'm going to be using for these 3 variables is float. Why float? Well, because the lengths of sides of a triangle can be decimal point number or floating point number. So float. And then let's put this arrow here so that you can visualize the flow of our program. It goes like this. And then after our user has inputted the side lengths, what we should do is we should determine whether he has entered equilateral triangle, isosceles triangle, or scalene triangle. And what I'm going to do next is I'm going to use this diamond shape here which indicates decision in your program. And what I'm going to put inside this shape here is condition. The first thing that we want to check is whether our user has entered equilateral triangle. So whether these three sides are all of the same length, whether these three variables hold the same value. And let me make this a bit bigger. And inside here, I'm going to say, please check if my A is equal to my B, and also if my B is equal to my C, like this. So let me join these two. And I want to explain two things when it comes to this. First one is this operator here, this AND operator, these two ampersands. This is logical AND operator, and it is used as I'm going to just explain. So this expression here is going to result as true expression only in a situation where this here is true, and also at the same time this here is true. So in that case, this whole expression is going to result as a true operation. That is the logic behind this AND operator. And the second thing that I want to explain is following. So I have said here, please check if my A side length is equal to my B length, and also if my B side length is equal to my C side length. What you can also put here is, you can also say A, because we have determined here that these two are of the same length. So it really doesn't matter if you put here A or B, whichever you prefer. So in this situation where this results as a true operation, we are going this way. And what I'm going to do when this results as a true operation, as a yes operation, I am going to use this shape here. Let me just rotate it. I really don't see a shape that is this one, so that's why I'm using this reverse funnel shape, and I'm rotating it so that you can clearly visualize something that is being outputted from your program. Let me delete this text here and make it a bit wider, and I'm going to put text inside it. And what I want to write out in this situation here, where this results as a true operation, where this condition is fulfilled, is that our user has entered equilateral triangle because all three sides are of the same length. So let me write that out. So in case that this condition here is true, we are going to write out to our user that he has entered equilateral triangle. And then let's check the situation where this here results as a no operation. So in that case, we have to determine whether our user has entered scalene triangle or a isosceles triangle. And for that, I'm going to be using another of these diamond shapes, so another decision that we have to make. And let's put it here. And, oh no. And the next thing that we want to check is following. So I want to check, once I have determined that my user has not entered all three sides of the same length, I want to determine whether he has entered all three sides of a different length. So I'm going to put inside this shape here another condition, and I'm going to say following. So please check if my A is, if my A is not equal to my B, and also at the same time if my A is not equal to my C, and also at the same time if my B is not equal to my C, like this. So this is the next condition that we want to check, and this operator here is called not equal to operator, and it is really reversed from this equal operator. It has reversed logic. So in this condition here, what we want to check is whether my A side length is not equal to my B side length, and also at the same time whether my A side length is not equal to my C side length, and also whether my B is not equal to my C. And if this here results as a true operation, that means that all of these three side lengths are not equal. They all have the different lengths. So in that situation, we are going to go this way. And we are going to write out, let me copy this shape. And here I'm going to say, please write out my user that he has entered a triangle that has all three different side lengths. And that is going to be our scalene triangle, like this. Okay, so in the situation where this here results as a true operation, it means that all of these three are of a different length, and we write out to our user that he has entered scalene triangle. And then the situation where this here results as a no, because we have previously determined that these three are definitely not of the same length, and then we have in this condition here determined that these three are also not of a different length. What is left is that the two of these three sides are going to be of the same length. And that is going to be the situation where we write out to our user, well, I can copy this, and we write to our user that he has entered isosceles triangle. So let me write that out. Okay. So these three are three potential endpoints of our program. So three potential solutions to our problem. And after we write out to our user this or this or this, I'm going to really put this one diamond shape just to indicate that our decision has now come to an end. We have solved this problem, and we are going to join these paths in this shape here. So I'm going to put this and this like this. So now, after we have decided whether it's an equilateral triangle or scalene or isosceles, I can now say you can resume the execution of my program normally. So whatever I put after this shape here is going to be executed in either this case or this case or this case. And what is going to be happening after the shape here is just stop. So our program is going to stop, but you can put a lot of code here if you need to. So I'm going to say stop. And let me delete this, really, I don't need it. Okay, let's explain one more time this diagram. So after our program starts, our user should enter A, B, and C, which represent side lengths of a triangle. And I have used this float shape since those side lengths can be decimal point numbers. And after our user has entered that, we come to this decision point here. And what we want to decide here is, first thing, we want to check whether all of these three variables are of the same value. So whether he has entered three same lengths for a triangle sides. And in case that this here results as a true operation, we are going this way. And we write out to our user that he has entered equilateral triangle. And after that, we go this way, and our program stops. In the situation where this here results as a no operation, we want to check something else. So we are going this way, and we come to another decision point. And here we want to decide whether our user has entered a triangle that has all three different side lengths. So after we have checked that they are not equal, we want to check whether all of three variables are of a different value. And in case that this condition here results as a yes operation, that means that he has entered scalene triangle. But in case that this here results as a no operation, we can now clearly say that he has entered isosceles triangle, because we have checked here that these three sides are not the same, and we have checked here that these three sides are not different. So all of them are not different, and that means that two of them have to be equal. And in that situation, we go this way, and we write out to our user that he has entered isosceles triangle. And now we can go this way, and you can see that in this situation as well, our program stops. Here I have opened my flowchart and my Visual Studio so that we can just translate this diagram into our C++ code. So the first thing here is our user enters our A, B, and C side lengths. So let's declare three variables of type float, and let's call them A, B, and C. And now I'm just going to write out a message to my user so that he knows what he should enter. So let's say cout, and please enter A, and then B, and then C, like this. And then let's use our cin command so that he enters his values. Okay, let's say first thing that our user enters is going to be stored inside my A variable. After that, what he enters, please store that inside my B variable. And then the third value that he enters is going to be stored inside my C variable. So now that we have entered our side lengths of a triangle, we come here, so to a decision point, and we said that we represent this with if-else statement. So I'm going to write here if, and then inside these parentheses, I'm going to say this condition here. So please check, like this, please check if my A is equal to my B, and then also check is my B equal to my C, like this. And if this expression here results as true expression, I'm going to execute one block of code. And that block of code is going to be this one here. But if this expression here results as a false expression, okay, I am going to execute another block of code, and that block of code we represent with our else statement, like this. Okay. And then let's write this yes situation. So let's write here cout equilateral triangle. So like this. Oops, you should put that not in a quotation marks. Okay, so in this situation where these three side lengths are equal, we write out to our user that he has entered equilateral triangle. But in the situation where this here results as false, we have this else block to execute. And let's find out what is inside our else block. So it is this code here. And that is another if-else statement. So this if-else statement is really nested inside this one here. So it is nested inside this else block. So here in these brackets here, we are going to put another if-else statement. So let me write out if, and then inside these parentheses, we put our condition from this decision here. So from this diamond shape here. And I'm going to write out, please check if my A is not equal to my B, and then is my A not equal to my C also, and then is my B not equal to my C. So in this condition here, we check whether all of these three variables have different values here. And if they do, if this condition results as a true expression, I'm going to write out, let me just copy this, and then we are going to adjust it. I'm going to write out that my user has entered a scalene triangle, as you can see here. So when this goes in a yes way, we write out that message. So if this results as a true, we write out that our user has entered a scalene triangle, but if this here results as a false, then we are going to write out that our user has entered isosceles triangle. And let me copy this, like this. Okay, so we have nested this if-else statement inside this else block. So this if-else statement is going to execute only in a situation where this here results as a false expression. So this code here, if you find it a bit unreadable, I want to show you one trick, so one rule that you can really follow, and that is if you have only one command under this if or else statement, you don't need to use these brackets. So you don't need to say that you are going to execute a block of code, since you are not. You are going to execute only one command. So you can really delete this here, like this. And then also here, since we have only one command, both here and here, we can delete these brackets here, like this. Okay, so now this code is a bit easier to read. Okay, now, as you can see from this diagram here, it is literally translation of this here and vice versa. So this code here is a translation of this diagram here. And what it means is when our user enters 3 values for our sides of a triangle, first we are going to check whether all of these 3 sides are equal. If they are, our program is actually going to say that our user has entered equilateral triangle. But if this here results as false, then we are going to our else block, and then inside that else block we are going to nest another if else. So we are going to check another condition. We are going to execute this if else here, and this if else here is going to check following. So it is going to say, please check if all of these 3 variables are different values. So if all 3 sides of a triangle have different lengths, and if they do, we can say that that is a scalene triangle. But if they don't, then since we have already checked that all of them are not equal, and also we have checked here that all of them are not different, we can say now that definitely 2 of these variables are equal, and that means that our user has entered isosceles triangle. And that is the program that we had here. Okay, so I hope you liked this video, and if you did, this is a strong call to subscribe to my channel and to share it with anyone else who would like to learn programming, and I'm going to see you in my next video. Bye. Hi everyone, welcome to another video of C++ for beginners. In this video, I wanted to talk about operators in C++, and we are going to cover the ones that are used most of the time, but I'm also going to make a separate video for certain operators that have specific use in C++. So in this video, we will talk about the ones that are used most of the time and that you really need to know and understand. And also make sure to watch the entire video because I do have some important tips to give you when it comes to this that you really need to understand and that you will find handy for your future progress in learning of programming. The first thing that I wanted to explain is what are operators. You can understand operators as special type of functions that are used to perform certain calculations on arguments or operands, and then based on those arguments and on that calculation, they give you a new value. So the first type of operators that I want to talk about are arithmetic operators. And you are probably familiar with most of these. So there is operator of adding and subtracting, multiplying, dividing, and also one more operator that you may not be familiar with, which is the modulo operator. So all of these are arithmetic operators. And let me give you an example of how these are used. So I'm going to say cout, and then let's write out the result of 5 plus 2. Now let's add one end line. Okay, so this here is the operator of adding, and then these 2 are operands or arguments, and this here is going to perform certain calculation and then write that out to my console. So if I run my program, we get the expected result, which is 7. So these really behave as you would expect them to behave in maths. But there are certain rules that are specific to programming and that I want to mention. So this operator here, operator of dividing. Let me give you a simple example. If I say cout and then 5 divided by 2, and I add end line, what do you expect to see in this line here? Write that in the comments down below. Now I'm going to run my program, and you see that the result that I've gotten from this line here is 2. But why has that happened? We know that 5 divided by 2 is 2.5. Well, there is a certain rule in programming that says that the result of dividing 2 whole numbers like this, so 5 is whole number and then 2 is also whole number, is also going to be represented as whole number. So even though the result of dividing these 2 is 2.5, that 0.5 cannot really be put inside integer variable, so it cannot be put inside integer container. So just 2 can be put here. And that 0.2 is really lost. If you want to show the real result of dividing these 2, what you have to do is you have to make one of these 2 or both of them of a different type, and that type is going to be decimal point number, so float or double. So if you put here 2.0 or you put here 5.0, then in this case you are going to get the result represented as decimal point number. So you can use it like this, or you can make just one of these of a floating point type. So you can say also like this. And then if I run my program now, you see that now I have got the expected result, so 2.5. That is one rule that you really need to know when it comes to this division operator. And another tip that I want to show you is this operator of modulo. So how do we use this modulo operator? This example here that I've just shown you, let me return this to this situation where I've been dividing two whole numbers, and we've just seen that 5 divided by 2 is going to result as 2. And that 1 that remains, we can get that 1 really with this operator here. So if you say cout and then 5 modulo 2 at end line, this operator here is going to give you the remainder of dividing two whole numbers, which are these two. So the result of this operation is going to be that 1. So let me run my program. And you see that we have gotten that expected result. So 5 divided by 2 when it comes to whole numbers. If you're dividing whole numbers, the result is also going to be whole number. And in this situation, it's going to be 2. And then that remainder after dividing two whole numbers, you can get with this modulo operator. And the remainder after dividing 5 with 2 is 1. And you get it with this operator here. So these 5 are really arithmetic operators, and these are also called binary arithmetic operators. Why binary? Well, because they are all used with two operands. They perform their calculation on two operands. There is also another type of arithmetic operators in C++ that are used or that perform calculations on only one operand, and those are unary operators. The examples of unary operators in C++ are this operator here, which is operator of increment, and then this operator here, which is the operator of decrement. So how these are used? Let me give you an example. So let's create a variable of type int, and let's call it counter. And I'm going to assign to that variable a value of 7, for example. So how this operator of increment works is it really increases the value of your variable by 1. So if I say counter plus plus, what this operator is going to do, it's really going to add +1 to my counter variable. So 7 plus 1, it should in this line here increase value of my counter variable to 8. And let's prove that. Oops, cout counter, and then let's add one end line. Okay, if I run my program, you see that we've got expected result. So 8. We've declared a variable of type int called counter. We've given it a value of 7. And then in the next line, we applied this increment operator to it, which had increased its value +1, so 8. And then after we write out that value of that variable, we got our result. So that is how this increment operator is used. This decrement operator, so counter minus minus, this decrement operator here works reverse. So it really subtracts 1 from this variable here. And if I copy this line here and then paste it, after this line here, our counter should be decreased by 1. So the value of our counter should really again be 7. And if I run my program, oops, like this, you see that we've gotten our 7. So we've gotten the expected result. However, there are specific rules when it comes to these increment and decrement operators. And let me explain what I mean on another example. So I'm going to create another variable of type int, call it counter2, and let's assign it also a value of 7. And what I want to do with this variable here is I want to write out its value, but I want to write out and increment its value in a single line. So I want to do this. So cout counter2 plus plus. And I'm missing this redirection sign here. Okay, so what are you expecting to see in this line here? We've seen that this line here has resulted with 8, and this line here should also result in 8. Let's see. Okay, run my program. And it didn't. In this line here, we have written out 7, but why has that happened? Well, this operator here is increment operator, but it is really post increment operator. And what that means is that whatever operation needs to be performed on this variable is going to happen first, and then this increment operation is going to happen. So that is called post increment. Another type of increment is pre-increment, and it is used like this. Okay, and this pre-increment means that whatever operation needs to happen on this variable here, first I'm going to increment it, and then I'm going to perform that operation. So if I run my program now, you see that we now get our 8, same as here. And that is because we have used this pre-increment, which first has increased our variable, and then our variable is written out. Okay, and the same is applied for decrement operator. So for example, if I say cout counter2 minus minus, and then, oh my God, again. Okay, and then if I run my program, you see that we have gotten the same value for this line and this line, so 8. And why that has happened is because we have used this post decrement here. So first our variable has been written out, and after that the value of that variable has been decreased. So just to prove that, I'm going to say one more time cout, and then counter2 without any increment or decrement, just to prove that the value of this variable has been decremented after it has been written out. So if I run my program again, you see that this line here has resulted in 8, and then this line here has resulted in 7. Okay. So you see that our console now is full of some random numbers, and it's really making it hard to read. So what I want to do is I want to clear out my console, but without deleting this code here. So how I'm going to do that? I'm going to use a command that is called system, and then inside these parentheses I'm going to say cls, which really is going to clear my screen. So if I run my program, you'll see that all of our code is still here, but console has been cleared. So that's because of this command here. That's a quick tip if you need to clear your console. Another type of operators that I want to talk about are relational operators. And these are really used to compare the value of two operands, so two arguments. And relational operators in C++ are following. So we have less than, and then we have greater than, and then less than or equal to, and then greater than or equal to. Then we have just is equal to operator, and then we have not equal to. So these 6 are relational operators in C++. And how these are used, let me show you in an example. So let's say that I'm going to create a variable of type int, call it a, and let's assign it a value of 5, and also create another variable that is called b and assign it a value of 5. So now, if I say cout, and then inside these parentheses, I'm going to say, please write out if my variable a is greater than my variable b. So if my 5 is greater than this another 5. Okay, and I'm using these parentheses because I want my cout command to know that this here is one expression that first should be calculated, and then whatever this expression here results in, I'm going to write that out in my cout command. So if I run my program now, you see that we have gotten 0. And if you know about how computers work, you know that they work on zeros and ones, meaning that 0 represents false and then 1 represents true. So in this situation, we have gotten the result of false. So when I ask my computer, is my A greater than my B? So is 5 greater than 5? It says false. No, it is not. Okay. And the same is going to happen if I put here this other operator of less than, like this. But if I, for example, put less than or equal to, so this operator here, and I run my program again, you see that now we have gotten the result of 1. So that is true. That is what our computer considers as true. So our 5 is less than or equal to 5, which is correct. And even better would be if we say just is equal to, and in this situation also we are going to get true as a result, like this, because 5 is equal to 5. And then how we use this operator here is like this. So you can say, is my A not equal to my B? And your computer really hears, is my 5 not equal to my 5? And the response to that is going to be no. It is false because these two are equal. It's the same number even though it's held by two different variables. Okay, I hope you understood these relational operators. And there is also one tip that I want to give you here, and that is, you see this comma sign here. This is also operator in C++. And it is not relational operator, but it is binary operator. And how this operator is really used, because we have seen it before without knowing that it was an operator, it is used as follows. So in this line here, we have said, please create a variable of type int, call it A, and assign it value of 5. And then also, so that is the purpose of my comma, so also create another variable of type int, call it B, and assign it value of 5. So my comma in this situation is operator and separator as well. So it is pretty intuitive. So before we continue, let's add one more of these clear screen commands here. And the next type of operators that I want to talk about are logical operators. And there are 3 of those. So we have logical and then a logical or, and then also not operator. So these 3 are logical operators. And they are usually used to combine 2 or more conditions into one single condition. And I'm going to show you that on an example. And let's use for that example these variables here. Let's just change the value of our b to 8, for example. So what I want to do is I want to write out following. So is my a equal to 5? And then also is my b equal to 5? I want to write out the result of this expression here. And you see that we have used our AND operator to combine these 2 expressions. So if I run my program, you see that the result of this is false. So that is the nature of our AND operator. It really works like this. It says, please check, is my A equal to 5? Yes, it is. And then also check, is my B equal to 5? No, it is not. It is 8. So then this operator says, okay, whatever, then this whole expression is going to be false. Because this operator here needs both of its operands, so this here, and then this here also, both of these need to be true in order for this whole expression to result as true expression. That's the nature of this AND operator. However, there is one more forgiving operator in C++, and that is this operator here. So this OR operator. And if I paste that here instead of our AND operator, and I run my program again, you see that this time we got different result. Now we have true, and that is the nature of our OR operator. So it says, please check if this is true or this here is true. Whichever of these results as true, then I'm going to be true expression. Only in the situation where this here is false and also this here is false, I'm going to result as false. In any other situation, this here is going to be true. So that is the nature of OR operator. And then we have also this not operator, which really negates whatever comes after it. So if I put it here, for example, you see that you've seen that previously this expression here has resulted as true expression. Now that I negate it, we are going to get false. So that is our not operator here. Okay. And there is also one more thing that I want to explain when it comes to the precedence of these operators, which means priority of these operators. So which operator types have the biggest priority? The biggest priority have arithmetic operators. After that come these relational operators, and then the smallest priority have these logical operators. So let me show you that on an example. Let's just comment this very quickly, and let's add another line, but the previous one that we had. So this here, like this, that is the operation that has resulted as false. So is my A equal to 5, and then is my B also equal to 5? And this has resulted as false. But if we, for example, say it like this, what do you think that this expression here is going to write out? So if I run it, you see that we have gotten 1. Why is that so? Well, as I've said, the biggest priority have arithmetic operators. So this expression here is going to be executed first. So 5 plus 3. After that, priority have these relational operators. So this operator here and this operator here. So after that comes logical operation. So this expression here is going to be really, is my A equal to 5? Yes, it is. And then also, is my B equal to 8? And the answer to that is also yes. So now both of these operands are true, and our AND operator is satisfied now, and it's going to result as true operation, this whole expression. So you need to remember that the biggest priority have arithmetic operators, so these here, binary and unary arithmetic operators. After that, we have our relational operators, and then the least priority have these logical operators here. Let's add one more of these clear screen commands before we talk about the last type of operators that I want to cover in this video, and those are operators of assignment. And there are 6 of those, and they are as follows. So operator that just assigns value, and then operator that adds and assigns, and then operator that subtracts and assigns, multiplies and assigns, divides and assigns, and modulates and assigns. So these 6 are operators of assignment. And let me show you how they work. So first I'm going to create a variable of type int, and let's call it x, and let's assign it a value of, for example, 5. Okay, so this here is example of this assignment operator here. And that is how it works. It assigns whatever is on the right to your variable on the left. So that is the direction of association. It really says whatever is on my right side, please assign that to my left side. And let me show you now how these here work, because they're a bit more complex. So if I say, for example, x plus equals 7, like this, what this expression here is going to do? Well, let me write out one more expression, and that is x equal to x plus 7. So this expression here and this expression here are just the same. This is just shorter way to write this here. And what this here does, well, this is expression that is not valid in mathematics, but in programming it is. And it does following. So it says, please, whatever is on my right side, assign that to my left side. And why it does that? Well, because this arithmetic operator here has priority over this assignment operator. So if you remember when we were talking about priority, these assignment operators have the lowest priority of all. So whatever is on my right side, that is x plus 7, is going to be assigned to my x variable. So 5 plus 7 is going to be equal to 12, and then that is going to be assigned to your x variable in this line here. And this expression here is really short way to write this here. Okay, so I'm going to comment this out, and if I write the value of my x now, we are expecting to see 12, and it is the result that we have gotten. So this x plus equals 7 is just going to do this, so this expression here. So it's going to add to my x this number here. And the same applies to these operators here. So this one that subtracts and then assigns or multiplies and assigns, divides and modulates. So if you say, for example, x minus equal to 7, then that is really going to result as x is equal to x minus 7. And then that right side is going to be assigned to your left variable, because arithmetic operators have priority over these operators of assignment. And if I run my program again, it really sees 5 minus 7, and that is minus 2. So I hope that you have understood these examples that I've just given you. And I'm also going to include some more examples at the end of this video, but tricky ones, so that you can be sure that you have really understood these operators in C++, because they are used very often and you have to understand them in order to continue with your progress on a programming path. So make sure to do those examples on your own. And if you come across any problems or you have any questions that are related to this video, write those in the comments down below and I'm going to answer them. I'm going to help you. And if you liked this video, make sure to subscribe to my channel and also click the bell icon so that you are first to be notified when I publish my next video. And I'm going to see you in my next video. Bye. Hi guys, welcome to my channel. In this video, I wanted to answer a question that I recently got, and that is a question that is often asked on job interviews, and also students get it on their exams. And that is a question on how you can swap the value of two variables. I'm going to give you two ways to solve this problem, but let me just explain what I mean by this. So I'm going to copy the text of this problem here, like this. And let me say that I have one variable, which is going to be called a, and that variable is going to hold value of 20, let's say. And then I have another variable, which is going to be called b, and that variable holds value of 10. And now I need to switch the value, so to swap the value of these two variables. I want my a to hold whatever my b is holding, and then I want my b to hold whatever my a is holding. So how we are going to do that? For the first explanation, I will need something, so let me get it. So here I have two glasses, and inside this left glass I have my green juice, and then inside this glass I have just plain water. And the question that we have in our Visual Studio is equivalent to a question how we can swap the content of these two glasses. And to solve that problem, I'm going to use another glass, so a temporary glass, and that is this one here. And I'm sorry guys, I know this is not a glass, it's a shaker, but it will do for this explanation. So what I'm going to do is I'm going to take this glass, this variable, and I'm going to put its content inside this third glass, this temporary glass. Okay, and then when I have saved the value of this glass inside this temporary glass, what I can do is I can put my green juice, so the content of this glass, inside here. Okay, this is a bit more complex in real life than in programming. So once you do that, you have saved the value of this glass here, so the content of this glass here inside this glass. And now what we are left to do is just to put whatever our temp variable, our temp glass was holding inside this glass here. And now we have successfully accomplished to solve this problem. So we have switched the content of these two glasses. And let's just translate this into our code. Now that I have explained the algorithm to solve this problem, we are just going to translate that algorithm into C++ code. So the first thing that I'm going to do is I'm going to create a variable, a temporary variable, which I'm going to call temp, and inside that temp variable I'm going to put whatever my a is holding. So I'm going to say that my temp holds now whatever is inside my a variable. And since we have our a variable free now to hold something else, I'm going to put my b value inside my a. So now my a is going to hold whatever my b is holding. And now that we have saved the value of our b inside our a variable, we can put inside our b whatever our temp variable is holding. So that is the value that previously was inside our a variable. And this here is really the algorithm to solve this problem using a third variable. And let's just quickly add a cout so that we can see what we have done. So our a is equal to a, and then our b is equal to our b. And let's add end line like this. And I'm going to add just a comma sign here. Okay, and if I run the program, you see now that here we have a is equal to 20 and b is equal to 10, and now we have successfully swapped the value of these two variables. So now my a is holding 10, and then my b is holding 20, which previously was inside my a variable. And this is a solution for our problem using a third variable. But this question is often asked in another way, and that is how you can swap the value of two variables without using a third variable. And now I'm going to explain that. So let me very quickly delete this until here. Okay. And in order to solve this problem without using third variable, you will have to think in a more mathematical way. And the solution for this is going to be the following. So the first thing that I'm going to do is I'm going to say, okay, let's say that my a variable is going to hold whatever my a is holding, and I'm going to add whatever my b is holding also. And this expression here would be really incorrect in any mathematics, but in programming this is a valid expression. And it means this here, whatever this expression results in, I'm going to assign that to my a variable. And this here is whatever my a is holding plus whatever my b is holding. Assign that to a. So that is going to be a, so 20, plus b, 10. That is equal to 30. So now in this line here, my a is going to hold the value of 30. And then in the next line, let's say now my b is going to hold whatever my a is holding, and then subtract whatever my b is holding from that. So in this line here, I'm going to say store inside my b the result of this expression here. And this expression will result in following. A, so 30, minus b, minus 10. That is going to be 30 minus 10, 20. So in this line here, my b is going to hold the value of 20. And then what we are left to do is just to put the correct value inside our a, and that is going to be a equal to a minus b. This means whatever my a is holding at this very moment, and that is 30, minus whatever my b is holding at this very moment, and that is 20. And guys, 30 minus 20 is going to result in 10, and our a is going to get the value of 10 in this line here. So now if I write out cout a is equal to a, and let's add end line, and then cout b is equal to b, and if I run my program, you see that I'm going to get the expected result. So my a now is holding whatever my b was holding, so 10, and then my b is holding this value that previously was inside our a variable here. So we have solved this problem in two ways, so with or without a third variable. So if you found this video helpful, make sure to like it and to subscribe to my channel. And also any questions that you have, leave those in the comments down below and share this video with anyone who'd like to learn programming. And I'm going to see you in my next video. And also, guys, one question for you. If you have any recipes, any algorithms on how you can make green juice taste and smell good, please make sure to write those in the comments down below. Bye. Hi guys, welcome to my channel. Welcome to another video of C++ for beginners. I just got an idea of a simple and fun program that I can show you how you can build. And since I'm a bit of a fitness enthusiast myself, if you haven't noticed, I wanted to show you how you can build your own body mass index calculator. So stay tuned, make sure to subscribe, and let's build our own BMI calculator. Okay, so here's the text of my task, and what we are going to build is BMI calculator. So first I want to explain what is BMI calculator. It is body mass index calculator that is going to tell you whether you are underweight or normal weight or you are overweight, depending on your weight and your height. And here I'm going to use weight in kilograms and then height in meters. So if someone else wants to adjust this program so that it can work with pounds, feet, and inches, you can write out that code in the comments down below, and the first one that gets it right, I'm going to pin that comment so that everyone else can use it and see it. Okay, so we are going to use this formula here, which is used to calculating your BMI in metric system. So another thing that I want to mention is these three categories here. There are also some more categories that you can really calculate whether you are extremely underweight or you are extremely overweight, but these three should be enough for us to do now, and these three I'm going to cover in this code. Another disclaimer that I want to make is that this BMI calculator probably should not be used by people that have huge amounts of muscle, so professional bodybuilders, because even though they have muscle, that muscle is still weight. So even though they are not overweight, they will fall in a category of overweight because their BMI is going to be higher. But for most of us that don't have a lot of muscle or are leading normal lives, training a couple of times a week, maybe this is going to be completely okay. So let's build our program now. So here is our tool that we are going to use to draw this diagram. So Lucid Chart. And let's really develop the algorithm for solving this problem. And then we are going to translate that diagram, that algorithm, into C++ code. So as you may already know, first thing that I'm going to put here is this shape here that is going to indicate the start position of my program, this circle shape here. And after that, we really need two things from our user. So two things that he should enter. And those are his height and his weight. So let's use this funnel shape here that is going to indicate something entering in your program. So visual representation. That's why I'm using that funnel shape. And inside here, I'm going to put two things that my user needs to enter. And those two things are these two things here. So his weight, and he should enter his weight in kilograms, and also his height, and let's say that he should enter his height in meters. So I'm going to use metric system for this problem. Okay, and let's indicate the flow of our program. It should flow like this. And after our user has entered his weight and his height, there is a simple calculation that our program needs to perform. And that calculation is going to be a process for our program. So the shape that I'm going to use for that is this shape here. So this shape that says process on it. And what our program should process, what our program should calculate, is it should calculate BMI. So I'm going to put here BMI is equal to, and then I'm going to put this formula here that is used to calculate BMI. Okay, so it's weight represented in kilograms divided by height to the power of 2. So I'm going to multiply my height with height. Okay, and this is really the calculation of our BMI. And now, after our program has calculated this BMI, what we are left to do is we should, depending on this BMI, really write out to our user whether he's underweight or overweight or of a normal weight. So we should make a decision depending on this BMI. And for that decision, we are using this decision shape, so this diamond shape. And inside this diamond shape, I'm going to put a condition. And that condition is going to be, let's first check whether my BMI is lower than 18.5, like this. And in this situation where our user's BMI is lower than 18.5, so when this condition here results as yes, I am going to write out something to my user. And let me find a shape. Okay, let's rotate this shape and delete is text. Okay, and what I want to write out to my user, how I can make this smaller. What I want to write out to my user in the situation where his BMI is lower than 18.5 is I want to write out that he is really underweight. So let's put text inside here and let's write out that he is underweight. So that is going to happen in this situation. Oh my God. That is going to happen in this situation here. Let me just, okay, now it's okay. So in this situation where his BMI is lower than 18.5, we are going to write out that he is underweight. But in the situation where his BMI is not lower than 18.5, we have to check something else. And let's check. So let's add another of these diamond shapes. Where is it? Here. Okay, and let's now check whether his BMI is higher than 25. So I'm going to write out BMI greater than 25. Okay, and that is going to happen in the case that this here results as no. And in the situation where user's BMI is higher than 25, that really means that our user is overweight. So we are going to write out, okay, so we are really going to write out a message to our user. So let's copy this shape here, which we are using to write out a message to our user. So this reversed funnel shape that represents something leaving your program, something being outputted from your program. So in the case where this calculation here results as true, we are going to write out to our user that he is overweight, like this. Okay, and let's really adjust this. Now it looks a bit more presentable. Okay, so first we have checked whether his BMI is lower than 18.5. If yes, we have written out underweight. If no, we have to check whether his BMI is greater than 25, and if it is, it means that he is overweight. But in the situation where this here results as a no, that means that our user's BMI is not lower than 18.5, nor it is greater than 25. So that means that his BMI is really somewhere in between, so between 18.5 and 25, and that is a normal BMI. So that is our last possible situation where we are going to write out to our user that he has a normal weight. So let's write out normal weight. Okay. So after we have covered these three cases, let's just join our flows into one. So I'm looking for this shape here, and I'm going to make it smaller, delete this text from it, and I'm really just going to join these flows inside this shape here. Let's just try to move this here. I'm going to delete it, and let's say that I'm going to, oh no. Okay guys, I had huge problems trying to adjust some arrows, so I had to rewrite this whole diagram, and I believe that I made it a bit prettier. So here we were explaining that in the case that our user has BMI lower than 18.5, we are going to write out this message to him. In the case that his BMI is not lower than 18.5, we are going to check whether it is greater than 25, and If yes, we are going to write out that he's overweight. If no, we are going to write out that he's of normal weight. And in each of these three cases, we are coming here to this diamond shape here, which is just going to join these three potential situations. And after this diamond shape here, we are going to write out to our user what his BMI really is, because I really want my user to know if he's, for example, in this situation here or in this situation here, I want him to know whether his BMI is, let's say, 18.4, so he's not that extremely underweight, but he's just a little bit underweight. Or in this situation here, I want him to know whether his BMI is 25.5, so he's just a little bit overweight, or his BMI is really 35, let's say. That's why I want to write out my BMI to my user, his BMI to my user, okay? So, and then we just really stop our program. So now I'm going to copy this diagram and put it next to my Visual Studio so that we can really translate this diagram here into our code. So here I have put this diagram and then also my Visual Studio. And let's now translate this diagram. Let's translate this algorithm into code, because this here really is an algorithm explanation on how to solve a certain problem. So the first thing that needs to happen is our user should enter his weight and his height. And for that to happen, I first need to declare variables for weight and height. And for that, I'm going to use type float, because his weight and height can be decimal point number. So I'm going to say float, and then I'm going to say weight and height. Okay, like this. And after that, let's put a message out to our user so that he knows that he should enter his weight and height. So I'm going to say cout weight, and let's put that he should enter his weight in kilograms, and then also height, but he should enter his height in meters, like this, so that he knows which system he should use. Okay, after we have written out this message here, what I need to do is I need to use my cin command so that I can allow my user to enter weight and height. And I'm going to say, first thing that my user enters, that's going to be stored inside my weight variable. And then after that, the second value that my user enters is going to be my height. So store that in a height variable, like this. Okay, and after we have entered weight and height, next thing that needs to happen is we need to do this formula here and really calculate our BMI. And in order to store this result, the result of this expression in our BMI, we need a variable for that, and that variable is obviously going to be called BMI. So let's add here, in this line here, let's add BMI. So I'm going to declare another variable, and that variable I'm going to use now, and I'm going to say that my BMI is going to be used as follows. So I'm going to use this formula here, which is our weight divided by our height to the power of 2. For now, I'm going to use it like this. Okay, and in this line here, we have really calculated our BMI, so this code here. And now, after we have calculated our BMI, what we should do is we should really check what is the value of that BMI. And for that, we are using this shape here, which really translates into if-else case. So first I'm going to say if, and then the first thing that I want to check is if my user's BMI is lower than 18.5, like this. And in this situation where his BMI is lower than 18.5, I'm going to execute one line of code, so that's why I don't need to put these brackets. So I'm going to delete them because I just want to execute one line of code, and that line of code is going to be indented here so that it is easier to read. And that line of code is really going to be a message that I want to write out to my user, and that message is going to be that my user is underweight, unfortunately. Okay, and let's add one end line like this. Okay, this is in the situation where his BMI is lower than 18.5. In a situation where his BMI is not lower than 18.5, we are going to execute something else. So that something else we represent with else statement. and I'm going to put that else statement. And what is happening in that else case? It is happening another if else. So here we have a situation where we need to check something else. So here I'm going to put else if. So if this here results as no, please then check something else. And for that we use this else if statement. So I'm going to say else if, please check if my BMI is greater than 25 then. So in this situation, we also want to execute one line of code, and that line of code is going to be to write out to my user that his BMI is greater than 25, which means that he is overweight. So let me copy this message here, and we are just going to adjust it. So I'm just going to say, you are overweight, like this. Okay, so if his BMI is less than 18.5, I'm going to write out that he's underweight. Else, if his BMI is not lower than 18.5, I'm going to check whether his BMI is greater than 25. If yes, I'm going to write out that he's overweight. If no, we are also going to execute something else. And that is this situation here. So in this case, he has a normal weight. So let me again copy this message here. And let's really put here a normal weight like this. Okay, so in this situation where his BMI is not lower than 18.5, nor it's greater than 25, we are going to write out to our user that he has a normal weight. And with this here, with this code here, we have really covered this part of diagram here. Okay, and then after this code here executes, we really want to write out our BMI to the user. So we have to translate this shape here, which really translates into our cout command. And we want to write out your BMI is, and then let's write out BMI like this. Okay, and this line of code, as you may already see from our diagram, is going to execute in either this case or this case or this case, because after we have finished with this decision part, we have executed only this part of code or this part of code or this part of code here. So whichever of these three has been executed, after this code here, we are going to execute this line here in either this situation or this situation or this situation. And that is going to be writing out to my user what his BMI really is. And that is the last thing that we need to put. So the last part of our code. And now if I run my program, okay, it asks me to enter my weight and my height. And my weight is, I believe, 66 kilograms, I think. And then my height is 1.75. So let's press enter. Oh no, I'm overweight. How my BMI is 66? Okay guys, for a moment I thought that I am overweight, but I am not definitely this 66 BMI overweight. So that means that we have a bug. So where are you, sneaky little buggy bug? Well, if you can see where our bug is, then write that in the comments down below. And I already see where potentially our bug could be. So this formula here, it should really go like this. So we should divide our weight with our height to the power of 2, which means that we should put parentheses here, like this. And that is this calculation here. So in this situation, our weight is going to be divided with our height, and after that, that number is going to be multiplied with our height. So we are going to get larger BMI than we should really. So we should put this code here in parentheses. So that was the first bug that really happened in these tutorials. Okay, I'm going to leave this part. I'm not going to edit it out. Okay, and now if I enter my weight, let's see, 66, and then my height 1.75. Okay, So I am 21.5. That is my BMI, and I am of a normal weight. So we have really built our BMI calculator, and this is the formula that you should use for a metric system. And if someone else wants to rewrite this program for pounds and inches and feet, you can write that in the comments down below. And as I said, I'm going to pin that comment up so that everyone can see it, if you of course get it right. I hope you liked this video. If you did, make sure to write it in the comments down below, and I'm going to put more videos like this. And also subscribe to my channel and click the bell icon so that you are first to be notified when I publish a new video. Share this video with anyone who would like to learn programming, or also with fitness people that would just like to use this program. And if you don't know how you can run this program without using Visual Studio, I'm going to link my first video here. And at the end of that video, I'm explaining how you can run the program from Windows, and that should give you an idea on how you can really share your applications with other people. So make sure to subscribe, like, leave a comment, share, whatever you want, and I'm going to see you in my next video. Bye. Hi everyone, welcome to my channel. Welcome to another video of C++ for beginners. In this video, I wanted to explain the concept of ternary operator, also known as conditional operator, and also some people call it shorter version of if-else statement. It is an important concept that you are definitely going to come across in your programming career, and you should understand it. And I'm going to explain this concept through building fun and simple program that is going to be a guessing game. So let's explain the rules of this game. We need to have two users, and our first user, which I'm going to call host user, has to enter a number. After that, we have to delete that number from our console so that our second user cannot see it. And then after that, our second user, which I'm going to call guest user, has to enter his guess so that he can guess what number our first user has entered. So this way we can really make a fun program and learn an important concept at the same time. And at the end of this video, I'm going to give you an idea or multiple ideas how you can really upgrade this program on your own. So make sure to watch the entire video. Now that we have explained the rules of this game, let's start building our program. And the first thing that we need to do is create two variables. Since we said that our user is going to be guessing numbers, those two variables are going to be definitely a number type. And let's say that that type is going to be integer, so integer numbers. And we need two variables. The first one is going to hold our first user number, so our host user number, and then our second variable is going to hold the number that our guest user enters. So let's call those two host user number, like this, and then the second one let's call guest user number, like this. Okay, and now after we have created these two variables, the next thing that we need to do is let's write out a message to our host user so that he knows that he should enter a number. So let's say cout, and let's just say host, like this, so that our host user really knows that he should enter a number. And I'm going to accept that number in my console using the cin command, and I'm going to store that number inside our host user number variable. So with this line here, we have entered our host user number. And what we have said at the beginning of this video is that after our host user enters the number, we really need to delete that number from our console so that our second user is not able to see it. And the command that I'm going to use for that is going to be this command here. So I'm going to say system, and then I'm going to say cls, which is really going to clear our console, so clear our screen. And now if I run my program, let's see how far we have made this program. Here we have this line, this seventh line, which says host user, and it expects our host user to enter a number. So I'm going to say, for example, 7. And then after I press enter, this number here really is deleted. So our console has been cleared. And now after this, we need to ask our guest user to guess the number that our host user has entered. So I'm going to stop the program, and next we need to write out a message to our guest user. So I'm going to say guest, like this. And after that, we need to accept what our guest user enters inside our guest user variable. So I'm going to copy this line here, like this. And instead of accepting that value inside host user number, I'm just going to change this to guest user number. And after this part here, we really have both accepted our host user number and our guest user number. And now we need to compare these two and see whether our guest user has guessed correctly our host user's number. So how we can do that, if you are familiar with if-else statements, and I'm going to link that video here, and if you are familiar with them, that is really one way to solve this problem. So you can solve this problem with if-else statements, and I'm going to do that, and then we are going to really convert that if-else statement into a ternary operator. So how we can solve this with if-else statements? Well, it is quite simple solution. So we have to say if, and then inside these parentheses, I'm going to really compare these two numbers. So host user number and guest user number. So I'm going to say host user number is equal to guest user number, like this. And then if this here results as true, so if these two numbers are the same, we can write out a message to our user, and that message is going to be, let's say, correct, like this. So our user has guessed correctly. But in a situation where this here results as false, we can use our else statement. And in this else situation, let's write out a different message to our user. So let's say cout, and then inside these quotation marks, let's say failed, like this. So that in the case where these two are the same number, we can write out to our user that he has guessed correctly, and then in a situation where these two are not the same, we can write out to our user that he has failed in guessing. So if I run my program now, you see that it expects our host user to enter a number, and I'm going in this situation to take the role of both host and guest user. So I'm going to enter 7, for example, and then you see that that 7 number has been deleted from our console because of this command here. And now our program expects our guest user to enter his number. And I even forgot what number I entered. So let's say that our host user has entered, for example, 11. And you see that our program says you have failed, so you haven't guessed correctly. And one more time, let's enter for our host user number 5, for example, and then let's say that our guest user also says number 5, and our program says you have guessed correctly. So this is one potential solution for this problem, but I wanted to show you how you can solve this problem using ternary operator. And now I'm going to comment this code here, like this. So this is a comment for multiple lines of code. And let's really translate this part of code here into a ternary operator, like this. Okay, so how does the ternary operator work? Well, it is the only operator that takes 3 operands or works on 3 operands. And the first operand is going to be a condition. So I'm going to copy this condition here, which is our host user number equal to our guest user number? So that is going to be the first operand. And after that first operand, we need to put this question mark. And then after this question mark, we have the following behavior. If this expression here, so if this condition here is true, we are going to execute one line of code, or actually one part of code, and that is going to be this line here. But in the situation where this here results as false, we are going to execute whatever we put after this column sign. So that is going to be our cout failed, like this. And this is really the syntax for our ternary operator. And as you can see, it really is a shorter form of if-else statement. So this line of code really means, please check this condition here. And if this condition here results as true, execute this part of code here. But if this code here results as false, please execute whatever I put after my column sign. So that is going to be our cout failed. And now if I run the program, it asks again for our host user to enter the number. Let's enter number 9, for example. And then our guest user has to guess the number. So let's enter, for example, number 3. And you can see that our program says to our guest user that he has failed in guessing. So there are a couple of ways in which you can really upgrade this program, and I'm going to give you a few ideas. And the first one is, for example, you don't have to use int type here. So you can use different data type. You can guess characters, or you can guess even strings if you know how to. And if some of you want to play with that and try that on their own and you get it right, make sure to paste that code in the comments down below, and I'm going to check it. And if you get it right, I'm going to pin that comment up so that everyone else can see it. So that would be one way of upgrading this program. Another way to upgrade this program is to make it easier to your guest user. And how do I mean easier? Well, you can really limit your host user to enter a number that is going to be in a certain interval. For example, you can say to your host user that he can enter only a number that is going to be between, let's say, 1 and 15 or 50. It depends on how difficult you want to make it to your guest user. And that will be one way also of upgrading this program. And another, and the best way of upgrading this program, is going to be when we learn loops. And when we do that, I'm going to link the video here. And how you can upgrade this program using loops. Well, you can give your guest user multiple attempts. So you can say, for example, let my guest user guess 3 times or 5 times before I say game over, you have failed. Okay. So I hope that you have liked this video, and if you did, make sure to subscribe to my channel, share it with your friends and with other people that would like to learn programming, and I'm going to see you in my next video. Bye. Hi guys, welcome to my channel. Welcome to another C++ for Beginners tutorial. And I'm really excited for making this video because this video is going to be a milestone. And in this video, I'm going to show you how you can build your own calculator application. So if you have watched my previous videos and you are also watching this one and you build this application together with me, you should really feel proud of yourself because you have made a great progress. So let's build that application now. Here I have opened my Visual Studio, and let's very quickly explain what we want to do before we start write code. So I want my user to enter 2 numbers and also operation sign, and then depending on those 2 numbers and that operation, we want to calculate the result and then write that result to our user. So the first thing that we need to do is we need to declare variables that are going to hold those numbers and that operation sign. And since we want our user to be able to enter decimal point numbers, so not only integers, but decimal point numbers as well, we are going to declare variables that can hold decimal point numbers, and those can be float and double. So let's declare float variable, for example, and let's call it num1, which is going to hold our first number, and also another one, which is going to be called number2 and hold our second number. And after we have declared these 2, let's also declare a variable that is going to hold our operation sign. And since that is a character, we need to use a character type for that variable. So let's say char, and let's call that variable operation, like this. Okay. And now, after we have created these 3 variables, we can really allow our user to enter his numbers and his operation. And we want to do that in the following order. So we want to say cin, and then first our user has to enter the first number, and then after that we want our user to enter the operation sign. So let's say operation, like this, and after that our user has to enter the second number. And this window here, guys, this is called IntelliSense, and it really makes your code writing easier. So you can navigate this list here using your arrows, and then you can also use tab key so that it finishes your variable name for you if you want that. Okay, So now we have entered our first number, our operation, and then our second number as well, like this. And another thing that I want to write out to my user, because this is going to be the best calculator ever, let's write that title to our user. So let's write here, before he enters anything, a quick title. So let's say Cout, and then let's say that it's going to be called Code Beauty Calculator. You can call yours whatever you want. So like this, and let's add these here so that it looks prettier. Okay, and now if I run my program, well, you see that it really looks like this. And now we are able to enter one number. After that, we want our user to enter operation like this, and then we want to enter the second number like this. And then after we press enter, our program should really calculate the result of this operation. In this current situation, it is not really doing anything else because we haven't written code for that. Okay, so now let's solve this problem that we have here. So at this point, you should really have an idea yourself on how to solve this problem using if-else statements and also nested if-else statements. So if you're not familiar with those, I'm going to link one of my previous videos here. So make sure to watch that video as well. But in this video, I want to show you the more appropriate way for solving this particular problem. And that is going to be using switch case statement. So what is switch case statement? Well, switch case statement is, as well as if-else statement, used when you want to execute a block of code depending on a certain condition, so depending on a value of a certain variable. But switch case statement is particularly used in a situation where that variable can potentially hold a lot of different values. And if you look at our operation variable here, you should really notice that this variable can hold 6 different values. And what are those 6? Well, our user can decide to enter operation for adding, subtracting, multiplying, dividing, modulating, and then what if our user does not really want to use our application, but he wants to hack it? So if he decides that he doesn't want to enter one of these 5, but he really enters some non-valid arithmetic operation, we should also cover that case. So we should really, as programmers, predict all these 6 situations and cover all these 6 cases. I'm going to add one end line here so that my text is formatted nicely. And then let's really show how this switch case statement is used. So the first thing that I want to write is switch, like this. And then if you press tab, you see that you are getting some default syntax for this switch case. For now, I'm going to delete that, and I want to show you how you can really write that yourself. And inside these parentheses here, I want to write out the name of my variable that I want to switch through or switch on. And that is going to be my operation variable, because depending on the value of this operation variable, we are going to perform a different calculation on these 2 number variables. So I'm going to say here operation, and then in these curly brackets here, we really want to cover all our cases. So the first case, let's say that our first case is going to be a situation where our user enters minus operator. So I'm going to use these single quotes, and then inside these single quotes, I'm putting the value that our variable can potentially hold, and that is this minus operator here. And after that, I'm going to add this column sign here, like this. And then after this column sign, I really want to put out whatever code I need to execute in the case that our operation corresponds to this sign here. And what I want to execute in this case is I want to say Cout, and let's write out our first number, and then let's write out our operation, and then let's write out our second number so that our user really gets a nicely formatted text. And after that, I'm going to add this is equal to sign, And here we are going to put really our result. And that result is going to be our first number minus, because our user has entered this minus, so our first number minus our second number. So let's write out number 1 minus number 2, like this. And after we have covered this first case, we need to add one more keyword, and that is going to be break. And this break keyword is really used so that our switch case statement knows where our first case ends. So I'm saying here, whenever my operation is equal to this sign here, you are going to execute this code, and you should really stop executing that case when you come to this break statement. Okay, so this is going to be our first case. Our second case is going to be a situation where our user, let's say, enters this plus sign. And in that situation, we really want to write out to our user this text here. So the same text, we want to really write out our first number plus, in this case, our second number, and then is equal to, and then we are going to add really this calculation here. So number 1 plus number 2, like this. And in this situation as well, we want to add this break statement at the end, like this. Okay, so these are two potential cases. And now I'm going to really write out the rest of them. So I have written out these remaining cases, and in each of these cases we really want to write out to our user his first number, after that his operation, second number, and then this equal sign. And then in each of these cases we are performing adequate calculation, so we are performing that operation that our user has entered and writing that result out to our user. And after each of these cases we really need to put this break statement. And you really have to put this break statement, because if you don't, you are going to get your program to behave as you don't want it to. And as you can see in this situation here, so in this situation where we are trying to modulate two numbers, we are getting an error. And if we hover over this number here, you can see that our error says expression must have integral or unscoped enum type. What does that mean? Well, if you haven't watched my video on operators, I suggest you to do so. I'm going to link it here. And here I'm quickly going to explain what is happening. So this operation here, this modulo operation, is operation that is really going to give you a remainder after dividing two whole numbers. And since this number here and this number here are of type float, we really cannot perform this calculation on these two variables. So what we have to do is we first have to check whether this number is really an integer number, whether it's a whole number, and this number as well. And since our float can hold decimal point numbers and integers as well, we really, in certain situations only, can perform this modulating operation. And let me explain what I mean by this, that our float can hold decimal point numbers and integers as well. Well, this variable here, this number variable, can really have a value of 5.5, for example, but it can hold as well value of 5.0, which is really integer value, so it's 5 only. So now what we have to do is following. I'm going to delete this line here, and we first have to check whether both of these numbers are integers, and in that situation only we can perform this calculation. But in a situation where one of these two or both of them are not integers, we are going to write out to our user that that operation is not valid. So I'm deleting this code here. And then let's create two variables. So let's create a variable of type bool, and let's call it is num1 integer. So this variable is going to hold a value that is going to tell us is our number 1 integer value. And let's also create another variable that is going to be called is num2 int, and as well this variable is going to tell us whether our number 2 is integer. And let's develop now an algorithm so that we can know whether our number 1 or number 2 is integer number. And I'm going to ask you to write your solutions in the comments down below. So pause the video, think about it, and then write your solution. And without using any already made functions, as programmers, as engineers, you should really be able to figure out the solution on your own. So applying the knowledge that you have gotten from my previous videos, or this one, but I'm going to say from my previous videos. So pause the video and write your solution. So this question is not really a question of programming, it's more of a question of thinking in a logical way. And if you remember when we were talking about casting operators, we said that a casting operator is used to convert one data type into the other. And I'm going to link that video here. If you haven't watched it, make sure to do so. And here we are going to try to convert our floating point number, so our number 1 and our number 2, into integer data type, so into integer number. And how we are going to do that? Well, we are really going to say int, so this here is going to cast whatever we put after it into int type. And we are going to say, please try to convert my number 1 into integer. And how does this work? Well, for example, if you have a number 1 that holds value of 5.7, when you try to convert that value into integer, what it does really, it says that 5.7, so that 0.7 part really, bye-bye. I'm going to take only this 5 part, so only this whole part of a number. So in that situation, we are really going to get only 5 from this 5.7 floating point number. So what I'm going to say now is I'm going to say whatever this expression here, this casting operation results with, I'm going to really try to compare that with the initial value of my number 1 variable. So I'm going to say num1 is my converted number 1, so converted to integer, equal to number 1, like this. And how does this calculation here work? Well, as I said, for example, if you have a number 1 that holds a value of 5.0, so 5.0, this part here is really going to take this 0.0 part of a number and delete it. It's going to keep only this 5, so only this whole part of a number. And after that, we have this is equal to operator, and then we are trying to really check whether that is equal to 5.0. And the result of this is going to be true. So with this here, we have checked really whether our number is going to be equal to our floating point number. So this result here, we are going to assign this value to our is number 1 integer variable. So here I'm going to say, please assign the result of this operation to our is number 1 integer variable, like this. And let's put this expression here, so this whole expression inside these parentheses, so that we really can see that this is an expression, and the result of this expression should be assigned to this is number 1 int variable. And now we are going to do the same for our is number 2. So I'm going to say is number 2 integer, and we are going to say that that is equal to, I'm trying to convert my number 2 to int, and then compare that to my float number 2. And after this, we really can now do our algorithm to perform this modulo, where it is this modulo operation on our two numbers in the case where both of them are integers. So here I'm going to say if is my number 1 int, and then also is my number 2 int, like this. In this situation here, I'm going to perform this modulo operation. And as you can see here, I have used only these two Boolean values here in this expression. So I didn't say, please check is my number 1 int equal to true, like this. Nor I have said, please check is my number 2 equal to true, like this. Because this part here, and this part here are really redundant. And what this expression here translates in, it translates in is true equal to true, and that is really redundant. So I'm going to remove this part here and this part here, and it should work fine like this for Boolean values, so Boolean variables. And in this situation here, where both of these are integers, we really can perform this modulo operation. So in this situation here, I'm going to take this code and I'm going to copy it like this. And I'm going to say, please write out my number 1, then my operation, then my number 2 is equal to sign. And then here I'm going to put adequate calculation. So I'm going to say, take my number 1, convert it to int, and then modulate that with my number 2 that is as well converted to int, like this. Okay, so in this situation where both of these are integers, we are going to really write out the result of modulating operation to our user. Let's add empty space here and here as well. But in the situation where one of these two is not integer, or both of them are not integers, I'm going to say else. And in that situation, I'm really going to write out to my user that this operation is not valid. So let's say just not valid, like this. So in any of these two situations, whether we write out this line of code here or this line of code here, after that we are going to come here, and here we have to put our break statement, like this. So after each case comes break. And now we can really test this part of code here that we have written. So if I run my program, the first thing that I want to test is, let's say, 5.5 plus 2.2. And we get the expected result, so 7.7. Let's run our program again. And this time I want to check whether my modulo operation is working as it should, because this code here is really specific. So let's say 5 modulo 2, like this. And as well, we have gotten correct result. And let's run our program one more time. And here I really want to trick my program and try to make it to modulate two numbers that are not whole numbers. So 5.2 modulated by 2. And as well, our program works as it should. So it says not valid operation. Okay. So if you have noticed, in this current situation, I really have to run my program each time that I want to perform a calculation. And that is because we haven't learned anything about iteration or loops so far. And those videos are coming. So make sure to subscribe to my channel and also click the bell icon so that you are notified when I publish those videos. And in that situation where we learn iteration and loops, we are really going to be able to run our programs indefinitely, which means to run our calculator application until we really decide to stop it. Okay, so after we have covered these 5 cases here, there is only one situation left to cover, and that is a situation where our user enters any other sign that is not one of these 5 here. And that situation we are really going to write like this. So we are going to say default. So in the case where our user enters operation that is not going to correspond to any of these 5 signs, we are going to execute our default situation. And here we really want to write out a message to the user that is trying to hack our program. So you can write whatever message you want to the user that is trying to hack the program that you have worked so hard to build. And I'm going to put here okay. You really can write out whatever you want to that type of user, like this. So in the case where our user has not entered this, nor this, nor this, nor this, nor this, which means our user has entered some other sign, we really want to write out not valid operation. And let's test now our default case. So I'm going to run the program. and I'm going to take the role of a malicious user that is going to try to hack your application, and I'm going to say, please try to perform this calculation here. So 5Z9. Not really. You have been smart enough to predict his malicious behavior, and you have said, if you haven't put here a valid arithmetic operation, then no, I cannot help you. This is not a valid operation. And there is really one thing that you have been wondering about for the most part of this video, and that is this break statement here. So why I have said that after each case you have to put break. And now you want me to explain that, do you? Do you really? Wouldn't that be a spoiler for a situation where you decide on your own to delete this break statement here and then run your program, even though I have said not to, and you enter some calculation and you remember that I have said that you are going to get unexpected behavior, but was she lying? Was she not? And then you decide to execute this calculation and boom, here's your unexpected behavior. So what has happened here? Well, your program has really recognized that this operation here that you have entered is this minus operation. And after that, it has written out this number 1, so 7, and then operation minus, and then this number 2, 5, is equal to, and then it has calculated number 1 minus number 2, which is 7 minus 5, and that is equal to 2. And after that, it has really continued executing other cases, which means it has come to this line here, and then it has written one more time your number 1 minus number 2, so 7 minus 5 is equal to, and then it has performed this number 1 plus number 2 calculation, and 7 plus 5 is going to be equal to 12. And then it has come to this first break command, and it has stopped the execution of your switch case. So why has this happened? It has happened because you haven't put this break command here, and in that case your program is really going to be executing your cases until it comes to the first break command. And if you have noticed here, in this default situation I haven't really put any breaks. You can as well put your break statement here. You can say break here, but even if you don't, even if you didn't put your break here, and your program really tries to execute something after this line here, there is really nothing to execute, so you are not going to get a problem in this situation here. I hope that you liked this video and that you have built your own calculator application, and if you did, make sure to subscribe to my channel and click the bell icon as well. Share this video with anyone who would like to learn programming, and I'm going to see you in my next video. Bye! Hi everyone, welcome to my channel. Welcome to another video of C++ for beginners. And in this video I wanted to deepen your knowledge of switch case. So if you're not familiar with switch case at all, if you haven't watched my previous video, you definitely have to do that. The link is going to be here. And in this video I wanted to give you some more examples that you can practice on and introduce some things that I haven't mentioned in my previous video as well. So in this video we are going to build a program that is going to require from our user to enter a year and a month as well, and then our program has to write out how many days there is in that month. So how we are going to do that, let's see. But first you have to subscribe to my channel and like this video and also share it with your friends. As I explained, there are two things that we need from our user to enter, and those are going to be month and year. So let's create two variables. Let's say year and month, like this. And now I'm going to write out the message to my user so that he knows that he should enter those two values. So year, and after that, please enter month, like this. And let's store now the values that our user enters. So the first one is going to be stored inside our year variable, and then the second one is going to be stored inside our month variable. And now we have really covered everything that we need from our user. Now our program has to check these two variables and then decide how many days there is in that month of that year. And we are going to do that using switch case statement. But there is one thing that I want to mention before we start write our switch case. And that is, you have to take in consideration that there are years that are leap years and that have one day more than the year that is not a leap year. and there is a rule for that. So I'm going to copy the rule that is going to help us to determine whether a year is a leap year or not. And that is this rule here. So any year that when modulated by 4 gives the result of 0, and at the same time that year modulated by 100 is not equal to 0, or a year, so that same year when modulated by 400 is going to give the result of 0. And this here is going to be a definition for our leap year, which means a year that has 366 days, or a February inside this year has 29 days. That's why we need this rule here. So now let's write out our switch case statement. And if you haven't watched my video on switch case statement, I am going to link it here one more time, because you really need to understand the switch case. And then you can come back to this video and deepen your knowledge on switch case. So switch, this is going to be the syntax of our switch case, but I'm going to delete this default syntax. We want to write it ourselves. So inside these parentheses here, I'm going to put the variable that we are going to switch through, and that is going to be our month variable, like this. So whichever value our user has entered for our month, we are going to cover all the potential values that our month can hold in our cases. So the first case that I want to cover is going to be the most specific one, and that is going to be our February, which means second month. So I'm going to say in the case that this month variable is equal to 2, which means that our user is requesting from us to determine how many days our February month has. We really, in this case, need to check whether that year is a leap year or not. And then if that year is a leap year, that means that our February has 29 days. And if not, which means if this condition here is not true, that means that our second month has 28 days. So I'm going to copy this expression here, this condition. And also, if you are not familiar with ternary operator, you have to watch that video, because in this video we are going to use that ternary operator. You can do it as well with if-else statement, but I want you to practice also this, because you are going to actually come across it in your programming career. So here I'm putting this condition for a leap year, and I'm going to say this question mark, and then I'm going to say if this here is true, you have to write out this line of code. So you have to write out cout, and if this condition here is true, that means that our year is a leap year, which means that our February, our second month, has 29 days. So let's say 29 days month, like this. Okay. And so that is in the situation where this here is true. And in the situation where this expression here results as false, I'm going to put here a column sign, and then I'm going to write out a different message, and that is going to be that this second month, in the case where a year is not a leap year, has actually 28 days. So after we have written this expression here, so this ternary operator, we have really written out how many days there is in our February month, and after each case I have to put break. So in this case as well, I'm going to put our break command after it. And with this example, with this case here, we have really covered our second month, which was the most specific one. Now we are left to cover the remaining months, which means ones that have 31 days and also ones that have 30 days. And here I'm going to show you something that I haven't shown you before. Let me scroll this code like this, maybe. Okay. And then there are some months that contain 30 days and some that contain 31 days. And the ones that contain 30 days are following. So I'm going to write out case like this. And then the first month that contains 30 days is going to be April, so fourth month. And then also our sixth month contains 30 days, and then also, let's see, 4th, 6th, 9th, and then November as well, like this. And here we have written out really all the months that contain 30 days. Okay, and now I'm going to, at the end, so at this case here, write out a message. Let me copy this, and I'm going to paste it, and I'm going to say 30 days month, like this. Okay, and I'm going to put break command here as well. So let me explain this part of code here, because we haven't seen this part of code here before. This break statement, what it does is when your program execution actually comes to this case here, it says, okay, my month is equal to 2, so I'm going to execute this part of code here. And then it comes to this break command. And this break command really breaks the execution of your switch, which means that when your program comes to the first break command, it is going to stop the execution of your switch there, which means that it is not going to check any more cases. And because of that, you can really here, so you can put more than 1 month. You can put all the months that have 30 days, like this. And then you can write out the same message and put one break command at the end. And how that is going to really behave inside your program, in the case where a user enters, for example, month 6, your program is going to check whether that month is equal to 2, and it's not going to be. Then it's going to check whether your month is equal to 4, not as well. And then it's going to come here and say, okay, this is 6th month that our user has entered. So please execute whatever code you find until you come to the first break. And that is going to be this here, which is empty, so nothing. And then this here, which is as well empty, so nothing. And then it comes to this code here. And that line, so this code here, contains this cout message, 30 days month. So it is going to write out this. And then it really comes to this first break command, and it breaks your switch, which means that it is not going to check any other cases that come after this break. Okay, so in any case, whether your user enters month 4 or 6 or 9 or 11, your program is going to execute this line here and then break your switch. So with this part of code here, we have really covered all months that have 30 days, and now we are left to cover the ones that have 31 days. And those are months, let's see, that is our January, and then our 3rd month, and our 5th, and our 7th month, like this. Let me scroll it a little bit more. Okay, and then we have as well case 8 and case 10, and as well our December has 31 days. So there are 7 months that have 31 days, 5 months that have 30 days, and 1 month that has 28 or 29 days. And in this line here, we are going to write out a message that is going to say 31 days month. And as well here, we have to put our break command, like this. Okay, so I am going to run my program now and show you how this program behaves. So our program is asking us to enter a year and a month. Let's say the year is going to be 2020, which is current year. And then a month is going to be, let's see, it's April, so 4th. And it says that it is a 30-day month, which is April has 30 days. And let's run our program one more time. And let's say 2020 again, and let's say that we want to check our 2nd month, and it says that February of 2020 has 29 days, which is correct as well. And there is really one more situation that I want to cover, and that is going to be a situation where our user enters a number that is not a valid month number. And that situation I'm going to cover with my default statement. So I'm going to write out default. And in this default case as well, I want to write out a message to my user like this. And inside here, I'm going to say not valid, which means that our user has not entered a valid month number. So let's run our program. And if I enter year 2020, and for a month, let's say -5, for example, you see that our program has written out not valid. Okay, so I hope that you have liked this video, and if you did, make sure to subscribe to my channel and share it with anyone who would like to learn programming as well. And today is May the 2nd. That's when I'm filming this video. I don't know when I'm going to publish it, probably in a couple of days. And currently we are a little bit over 900 people. So let's see how fast this channel can grow. Thanks for watching, and I'm going to see you in my next video. Bye. Hi everyone, welcome to my channel. Welcome to another video of C++ for beginners. And in this video I wanted to talk about loops, more specifically about while loop. So what are loops, what are they used for, how they are used? Well, loops are used when you want to execute a block of your code multiple times while a certain condition is true, which means you give a certain condition to your loop and you say you are going to execute this block of code while this condition here is true. So however many times it is necessary. And one thing that I want to mention before we start on our example is the following. So selection, sequencing, and iteration. Those three are three main building blocks of programming languages. And when you really learn and understand those three, you should be able to solve any logical programming problem. And in this video, we are going to talk about iteration. We have already talked about sequencing and selection in my previous videos. So what is sequencing? Well, that means that your code is executed sequentially, which means one line after the other. And then selection, that would be really when you want to select one part of the code rather than the another one, which means you are going to tell to your program under a certain situation it really has to select which block of code it is going to execute. The same would be when you, for example, come to a crossroad and then you have multiple ways in front of you, but you really have to select which one you are going to take, because you cannot take all of them. And then iteration is going to be really iterating or executing multiple times a certain block of code, certain part of code, while a certain condition is true. So while a certain condition is fulfilled, you are going to execute the same block of code. So let's see our example now. So I'm going to paste the text of my program here. And this is our task. So it says that we have to write out all the numbers between 100 and 500 that are divisible by 3 and by 5. And how we are going to do that. First, I want to explain you the algorithm, so how we are going to solve this problem, and then we are going to translate that algorithm into our code. So this interval here, so this 100 to 500 interval, we are really going to iterate through all of the numbers of this interval, and we are going to do that using while loop. And then for each of those numbers, so for each value of our counter, we are going to check whether that counter value can be divided by 3 and by 5. And if yes, we will write out that value. If no, we are just going to continue to the next iteration. So as I already said, we are going to use while loop to solve this problem. And we are going to start our while loop with the counter value of 100, and in each iteration we are going to really increase the value of our counter, so 101, 102, and 3, and we are going to stop the execution of our while loop when this counter value comes from 100 to 501, which means 500 value of counter is going to be our last iteration through our loop. So the first thing that I'm going to do is I'm going to really declare a variable that is going to hold our current counter value. So I'm going to call it int counter like this. And initially, I'm going to set the value of my counter to 100. Okay, so this is our initial value of our counter. And then let's see what is the syntax of our while loop. So we write out while like this, and then in these parentheses we are going to put our condition, so how long our loop is going to execute. And then in these braces here, so in this curly brackets, we are going to put which block of code our while loop is going to execute while this condition here is fulfilled. And let's now fill these parentheses here. So as I've said, our counter has to go from 100 to 500, which means since it starts on 100 here, we have to say to our while loop that the execution of this block of code here really has to stop when our counter comes to 500 or 501. 500 is still valid value. So that we are going to say like this. So we are going to say counter like this. And then we are going to say there are two ways to write this condition. The first one is to say while our counter is less or equal to 500, or you could as well set while our counter is less than 501. So that is a valid situation while you're executing your loop. So while your counter is less than 501, or while your counter is less or equal to 500. I prefer it this way, but whichever way you put it is going to work. So now that we have put this condition here, we really can write out this code that comes in this while loop block. So what we are going to execute while this condition here is true. And that is going to be following. Inside this block of code here, we really have to check whether our current value of our counter is divisible by 3 and by 5. And if it is, we have to write out that number to our user. If no, we just need to continue to our next iteration of our loop.